Morning, everybody. Welcome to the ETSI training session on its standards and for trust services for digital signature. I will kick off this morning's session. We've got a 4-hour session, so I hope you can stand it. We've put in 2 15-minute breaks after the first and just second hour, and we will be recording this session. The sessions are broken down into 20-minute topics presented by all my colleagues. As you will see on this session, we'll have a break at 12 o'clock Central European time and a further break at 1:15. At the end of the last session, we aim to have a session where some of your questions are discussed, but there is a questions facility on this webinar. So if you want to raise any questions during or after any of the sessions, feel free. We will either try and answer them during the session or at the end of the session, or if we can't answer them straight away, we will collect together the questions and provide written answers following the meeting. So I will kick off the discussion by just giving you some background information about our standardization. ETSI, that you're aware of, is an international organization, but we are based in Europe. We've got members from all around the world. We've got the largest number in Europe, but we've got quite a large number of members in North America. We've got members from around the world, including Asia and Australia and South Africa. So in our standards, we aim to meet the global requirements and fit our standards within a global context. However, we do recognize that we need to meet the requirements of European norms. This session was in fact supported by my colleagues in the Arab area in AICTO, who helped us set up this session. We've got liaison, and we work with Asia PKI. We've got close links and been working closely on mutual recognition with the Japanese over a number of years. And also we've got links with US and in particular the International Safe Identity Organization that provides identity and trust services to the health industry. So recognizing this dual nature of ETSI being a European organization that fits within a global context, all our standards in this area very much build on globally accepted best practice. We've worked with ISO, and recently there's an ISO standard 27099, which ETSI have contributed to ensure alignment. We've also worked over last decade closely with the CA Browser Forum, which provides PKI best practices for the browser and application community and works with the CA community. So we have very much founded ourselves in the international context, and all the standards are very much aimed at being internationally acceptable. And we've had our standards in trust services adopted in South America, the Arab and African region, and Asia region. So we've very much had global adoption. Where there are European specific requirements based on what you may have heard of called the EI- regulation or EI regulation 2910/2014, which is based on European trust services. We meet the requirements of this regulation through specific options within the ETSI standards, so you can apply the standards either as in a global context or where you want to meet European specific regulatory requirements. Then we include specific options within the ETSI standards for meeting European regulatory requirements. So I'll just very briefly, before I hand on to my colleagues, an overview of our general framework for standards. We've broken our standards down into the following 7 areas. First of all, we've got a set of general framework standards for signing devices, signature creation devices, trust services for signatures, and other trust services and status lists. And I'll just say a bit more about each of those in a moment. But we have a unified numbering scheme. So looking at the number, you can identify which area it relates to. And also we have the first digit in ETSI indicates whether it's a European norm, which means it's recognized under European regulations having specific legal effect, or a trust service, a technical specification, which is just a recognized standard which is less legally enforced. And then CEN, our partner European standards organization, have their own numbering scheme with their first number being 4. So you can ETSI standards start 1 or 3, and CEN standards start 4. The second digits 19, the second and third digit 19 relate to this area standardization, and then the next digit points to what specific area. So saying a bit more about the specific areas, in the general framework, we've got this standards framework which describes this numbering scheme and the overall organization of standards. We provide common definitions and also guidelines for each of the areas as an introduction to the standardization in each area. The next area, which marks one's XX, is for signature formats and procedures. So we have a set of signature format standards for different formats, which will be presented shortly. We also have procedures for signature creation and validation, which apply to all of those standards. We have worked closely with our partner standards organization, CEN, which define specific protection requirements for signing devices, including smart cards, and also remote signing for signing in the clouds and use of HSMs. We also have a set of standards, and in particular one standard which provides guidance on signature suites and algorithms which are recommended for use with our standards. We have a set of standards specifically aimed at signature creation and validation, applying digital signature public key infrastructure technology to both the legal requirement for electronic signatures and electronic seals. We have a set of standards for trust service, other trust service applications, including registered e-delivery and electronic mail and long-term preservation. And then moving on to the final area, we have a set of standards for trust service status lists, which will be described at the end of this session. So I'd like to pass on to, I think, if I can ask Andrea Rock to present. So I'll make her presenter and make her audio. So
yes,
over to you, Andrea.
Hello, I just a sec. Juan Carlos is here.
Okay.
Yes, I'm here.
Okay, on the nick of time. Can you, I presume, Juan Carlos, you'll present the...
Yeah. Yes, I can do that. Just, you should give me the hand then.
Okay, sorry, yeah. Let me find you. Right, make you presenter.
Okay, and how can I?
And now you should be able to share your screen.
I don't know how to do that. Okay.
It's on the main, if there's on the main options for the share screen. Oh, I'm sorry, I might, you know.
No, I think I got it. Okay.
My fault. We can see your screen, thank you. Yeah, but that's fine.
Okay. Okay, I will first introduce myself. My name is Juan Carlos Cruellas, and I work for the Polytechnical University of Catalonia in Spain. And I have been the editor of the EN 319132, which is Shades, and 319182, which is Jades, and also participated in the standardization of the rest of the formats about which I'm going to talk about now. Okay. This presentation will be split in two. In the first part, I will talk about the signature formats. I provide some hints, some quick hints on the signature formats. And this is the agenda for the whole presentation. And after that, Andrea Rock will tell you interesting things about the validation and the signature validation and signature validation services. Okay, we will start saying that signatures standardized by ETSI received the generic name of ADES signatures, and they built on the most relevant digital signature standards specified in different syntaxes. And we call them during this session underlying standards after. We've got up to 4 different specifications depending on the syntaxes. ASM in CADES, which is EN 319122, builds on CMS as a standardized by IETF, and builds on ASM1. We've got also JDES, which is it's built on the JWS, which are JSON web signatures, and which is using a JSON syntax. We have also defined a format for PDF, digital signature for PDF, which builds on PDF signatures, and it's called PADES. And finally, we built a format on XML digital signatures, which receives the name of SHADES. In addition to that, ESI has also specified a format for a container, which is able to include one or several data objects, meaning files, and one or more digital signatures, basically CADES for the moment, or timestamp tokens, or ERS, evidence records. I forgot to mention as well that CADES and SHADES also may contain evidence records within them. So ASIC, it's basically a format defining a container where you may place files that are either signed with CADES or SHADES signature, or timestamped with RFC 3161 timestamp tokens, or secured using an evidence record as defined by the IETF. One of the things that are critical for the specification of ADES signatures is the fact that all the formats, all the underlying formats that we mentioned, allow for the incorporation of extra information in the digital signatures. Some of these new additions are actually signed by the digital signature value itself, and we call this information signed attributes or signed qualifying properties, depending on specification, and others are incorporated after the signature the signature value has actually been computed, and we call this information unsigned attributes. So basically, and then each ADES standard has, in general, two specifications, except JDES. JDES is the last one, and for the moment, it only has one part. Also, we expect to produce the second part pretty soon. The first part is what we call building blocks and baseline, and the second part is what we call, generically speaking, extended formats. The first part, corresponding to building blocks and baseline, define basically a number of data types, which we call the attributes or qualifying properties that I already mentioned. The underlying formats placed in each basic format, a placeholder for putting their signed or unsigned attributes, and what ADES part 1 do is first to define new data types for the attribute signed or unsigned. They specify which of these new attributes are signed or unsigned, and they basically also finally define up to 4 different combinations of signed attributes and unsigned attributes. Each combination being used for satisfying a different set of requirements. Each combination provides a certain number of different features, which I will present later on. Part 2 define, basically, they do not define any, well, they do not define any new data type, but new combinations of attributes, where the degree of optionality is higher because the baseline signatures have one property, which is to reduce as much as possible the degree of optionality in the combinations of attributes for the sake of facilitating the interoperability of the implementations. Very briefly, I will mention some of the interesting signed attributes. Among the signed attributes, okay, you can, for instance, incorporate into the digital signature any attribute that you've got that the signer has, any attribute got, for instance, from the organization for which that signer works. They also allow to incorporate timestamp tokens on these data objects that have been signed as a proof that those signed data objects existed in a certain point in time. These signatures also allow to express in a secure way, which is the commitment endorsed by or taken by the signer when producing the digital signature. And among the unsigned attributes, the most interesting ones are those ones that allow to achieve what we call long-term digital signatures, which are signatures whose validation can be restated long time after their generation, regardless any of the certificates has expired or even has been revoked. And I will talk about that now. And this includes timestamp tokens on the digital signature itself for proving that the digital signature was generated in a certain point in time. Validation data, meaning not only certificates within the certificate path of the digital signature, but also certificate status data like OCSP responses or CRLs, which allow to proceed to replicate the validation long time after the end of the generation of the signature, and timestamp tokens on all the components of the signature, which we call archive timestamps, that prove that these components have not been changed since these timestamp tokens were produced and incorporated. We coined the term augmentation of ADA signature for referring to the process of incorporating unsigned attributes. And well, as I will, the next couple of slides will show an example of an ADA's life cycle. Okay, everything will start when the signer generates the ADAS, what we call the BB ADAS, the B from basic. And here you've got the document and the digital signature. And sometime after, someone generates, requests a timestamp token on the digital signature value, and it adds that timestamp token as an unsigned attribute. Okay, and this makes, well, this augments the signature from a BB level to a BT level, meaning a signature with timestamp token. Okay, in order to achieve a long-term signature, this signature can be augmented with a bunch of validation material. Here you've got all the certificates required for validating both the digital signature and the timestamp token, and also the CRLs and OCSPs responses. Okay, with this, signature contains all the validation material required for generating, for revalidating the signature. But one thing that we can also do is to augment everything by timestamping all this material, which means that this timestamp actually seals to some extent the contents, or all the contents of the signature. Okay, this means that if some algorithm is broken of some algorithms of the algorithms used in the digital signature or in the signature timestamp token, but not in the last timestamp token that we have added, well, these timestamp tokens protects the material present within the signature against this break in the algorithms. And still, you could duplicate, you could replay the validation of the signature. One thing that could also happen is that in a certain time, okay, some certificate required for this timestamp could expire. Okay, this can be countered by a new sequence augmentations. In this case, we would include the validation material for this first archive timestamp, and we would archive timestamp the complete new signature in such a way that, well, these augmentations through archive timestamps would protect in sequence all the contents of the digital signature. This is a life cycle, an example of life cycle. Regarding the AC containers, well, basically well, you've got one or two of more documents detached from the signatures. In this case, is Shades. Shades has as XML signature capabilities for explicitly referencing the files. And in the case that you've got a CMS or a timestamp token that do not have the capabilities for explicit references, then you include what we call async manifest that has explicit references to the signed documents or the timestamped documents, and also a reference to the signature, to the cadet signature or the timestamp which sign or timestamp these files. Okay, and this is all on the ADES signatures. Now, I guess that Andrea will provide on that.
Yes. Hello, everybody. My name is Andrea Röck. I'm working at Universign, a French qualified trust service provider, and I'm the rapporteur for several ETSI standards. So, for example, for the CADES format, the preservation standard, the remote signing standard, and I was part of the expert group working on the validation documents. And right now I will give you an overview of the different standards we have in the area of signature verification. Next slide, please. So the first document I will talk about is the EN 319-102 Part 1. It's about signature creation and signature validation, and it describes these processes in a format-independent way. So before already we saw we have different formats for each of them. We have a similar structure, and here we present in this document the structure is presented really in a format-independent way. We have 4 different classes. One is the basic signature, which is, as we've seen in the life cycle described by Juan Carlos before, we just have the document or the hash of the document, the signed attributes, which include the signing certificate, and the signature value, which will cover those elements. The next class is the signature with time, where we have in addition, the timestamp as an unsigned attribute. So this is the second class, where we have some proof that the signature was created before a certain time. Just a small comment on the terminology I'm using. I'm using time assertion instead of timestamp, which is a more general term, which kind of allows different techniques that provide a proof of existence. of the signature. It can be timestamp, can be evidence record, things like that. So to not always say one or the other, we use the term time assertion. The third class is the signature with long-term validation material. So we have the, in addition to the timestamp, which proves at which time the signature was created, we have also information like the certificates and revocation information for the signing certificate and any time assertion in the document already contained. But those are not protected. They're just put in the signature to have a place to store them. And then the fourth class is the signature providing long-term availability and integrity of validation material. And there, in addition to the, we might add some other validation materials that was not yet there. And what is important, we protect everything with a time assertion. So meaning we have a proof that all this validation material existed at this certain moment in time. And this allows to extend the lifetime of the signature, the moment until which it can be validated. Next point. So what we've described before, there are 4 signature classes. And for each of those classes, as Juan Carlos already mentioned, we have signature levels. And a signature level is an format-specific implementation of these classes. So I put on this sideline the corresponding name of the baseline profile. So it would be BB for the basic signature, BT for the signature with time, BLT for the signature with long-term validation material, and BLTA for the signatures with long-term availability and integrity of the validation material. Next, please. So the second content of this document is the validation procedure. How can we validate an existing document, an existing signature? So the whole document on how the process is based on building blocks, which are described one by one and are combined to 3 main validation procedures. The first one is for basic signatures. The second one is for signatures with time and signature with long-term validation materials. Those 2 are grouped together, meaning we have a signature where we have proof of existence of the signature and some validation material, which should be valid at the moment of the validation. And then the last class, the last process is validation for signature providing long-term availability and integrity of validation material. And in this case, the validation material we are using is not necessarily valid anymore, but we have a proof of existence that at which moment in time it was still valid. Those are the 3 main class processes. The result of the validation, there are 3 different main results. Total pass, meaning great, everything is correct as we want. Total failed is there was a big problem in the signature. And most of the time we will have indeterminate, which means we have, it's not sure. If we have additional information, the status might change, for example. And especially for this status, it's very important to have the sub-indications, which give more information why we could not end with total pass or total failed. Just to an example, in most cases, when you have, for example, a certificate revoked, we will not have total failed, because if we would have a proof that the signature was created before the revocation, then it would be okay. Only when we are sure the signature was created after the revocation, then we will have a total failed. The principle of this process is that for the same input, everyone implementing this algorithm shall have the same output. Meaning you don't have to follow the algorithm line by line, but the result must be the same. And we need to take into account that validation time is also an input. The process is controlled by constraints. So meaning it's very flexible. Depending on the constraints you set, sometimes something will fail, sometimes something will pass. The constraints can be set either by a signature validation policy, explicitly in the validation system, or implicitly by the validation. So explicitly meaning some configuration file, for example, implicitly really how the implementation is done. Examples of constraints are X509 validation constraints, like which are the trust anchors, are there any constraints on the path we want to construct. There can be cryptographic constraints, which are supported algorithms, where we think it's not safe anymore. And there are more general signature element constraints, which is more or less the rest. This can be something like, do we have information on if the certificate is qualified or not? Does it contain a certain attribute we want to have? So there can be a lot of constraints there. Another document that we have is part 2 of 119.102, and this is a signature validation report. This report, the idea was we have a structure where we explain what is needed to have an report that contains really practically what you might want to know. It's, for a general user, it's probably too much information, but it's really have a detailed information on what are the elements used. So already the status, of course, but also what are the elements used within the validation. What are the information on the signature, on the signed document, and yeah, what might be useful on looking on the final result. What is important? This report is an XML structure and can be signed, for example, with the XIDE signature, and therefore it's also very interesting to be used by a validation service, because a validation service needs to kind of give a result where it can say, yeah, this result comes from me, it was not changed. So signing it, the report is very useful in this case. Another, now we are in a family of documents, it's documents on signature, validation, creation, or augmentation policies. So we have four parts in this document. The first one is building blocks and a table of contents for human readable signature policies. This one describes what could be written in the validation, creation, augmentation policies. And this contains specific rules that are constrained, so really constrained how to create, validate, or augment signature. But it also contains applicability rules, meaning some set of rules for which audience those signatures are used. Is it applicable for a specific audience or not? Part 2 and part 3 are machine readable versions of the signature policies. So we have one in XML format and one in ASIN1 format. And the fourth part just was published yesterday, I think, is on a policy specific for the European area. It's for how to validate qualified electronic signature and seals using trusted lists. There it's based a lot on document TS 119-615, procedures for using and interpreting EU member state national trusted list. But this Olivier will talk about more about them later. Part 1 and part 4 contains two sorts of elements, the creation, validation, augmentation constraints, but also the applicability rules. For the machine readable part, we were concentrating on only technical constraints on digital signatures, not pure applicability rules. Then we have another set of documents. It's for signature validation service. The signature validation service, the goal of it is you send a signature and the service will tell you is the signature valid or not. We have two documents here. The one is the 119441, which are policy requirements for trust service provider providing signature validation services. It contains a main part with requirements for general signature validation services, the best practice, and then in an annex, specific rules specifically for qualified EU validation services, to be really kind of taking some of the extra requirements into account, and it's based on the main part. So the main part is the whole general part, and the annex is just a EU specific one. And then there is the 119442, which is protocol profiles for trust service provider providing ADAS digital signature validation services. So it proposes a protocol how to talk to a validation service. It defines a main structure of the protocol, and then we have two different bindings, one XML and one JSON syntax. So everyone can choose what they want to have, but the main capability is the same for both implementations. And both implementations are based on BSS-X Core 2.0. And then we are finished with the pure validation part, but I still want to talk about another document, which is quite important. It's a Cryptographic Suites 119312, often used called algo paper. And this document provides a list of recommended algorithms needed for signatures. So in general, when we have some requirements on what algorithms to use, we always say, okay, look on this document. It's a should requirement, but these are the recommendations, what a good best practice for algorithms for signatures. This contains recommendation for hash functions, signature algorithms, and key generation. The document, the recommendations in there are based not just on us, but they are based on the recommendation in the SOGIS crypto evaluation scheme, which is updated every 2 years. So ETSI is closely following this scheme and built on this their own recommendations. They contains recommended and legacy mechanism. What means recommended mechanism is this what you should use when you start now. Legacy mechanism are those that you can still use when you already have a running system and you don't want to change from one day of another. But there is kind of an end date for the legacy ones. So you should, as soon as possible, change to the recommended one. And it was a decision that non-recommended algorithms are not contained. There is no section on don't use this algorithm. If an algorithm is not in there, it's not recommended. Okay, that was all from my part for the moment. So I give back to Nick.
Yep, thank you. Thank you, Andrea. I'd like to pass on now to my colleague Sylvie, who will present the work on trust service for issuing certificates. So Sylvie, if you can unmute yourself. Okay, you're all ready to go. Over to you.
Yeah, thank you. I guess I have to take the screen.
Yeah, I think I've given you presenter rights. I'll try again, make presenter. Oh, sorry. I keep forgetting there's another button I need to press. Okay, you should be available.
Okay, yeah.
Yeah.
I received the order. Thank you, Nick. So I start with a short presentation. Hello, everybody. My name is Sylvie Lacroix, and I am a partner in SEALD, which is a Belgian consulting company specialized in e-identification and e-signature. And SEALD is a member of ETSI. And personally, within ETSI, I am a rapporteur for some technical specification or European norms, such as the norms for TSP issuing a certificate that I'm going to present right now. And then I'm also in charge of a special task force on identity proofing, and we will have a discussion on that later today. So let's start now with the presentation of standard for trust service provider. I just realized that I put on the screen the presentation for identity proofing, which is not the right one. So let's come back to the topic for now. The standard for TSP issuing certificates. Well, there are a series of specifications for TSP issuing certificates that are also called commonly certification authority. First of all, we have a norm, a European norm 31941, that provides general policy requirements for trust service providers as defined in EIDAS. So there are several types of trust service providers. Certification authority are one type, but you also have trust service provider offering remote signature, for example, or timestamping services and other similar services. So with this first document, we have the generic requirement for trust service provider in terms, for example, of documentation. They have to provide service policy, practice statement, general terms and conditions. So this is where we define what they have to do. And then there are specific requirements on the management and the operation of the trust service. Typically, you will find there requirements on the personnel, the need to have a screened personnel, well-trained. You will find physical security requirement on the buildings, specification for the security of the network, business continuity, incident management, and of course, what to do in case of termination of the service. So this is a document on which all the policy requirements for the specific services will be built. And the first one is a quite important one for certification authority. It's the norm 319411 part 1 that provides the policy and security requirement for trust service providers issuing certificates, all kinds of certificates, general requirement. And basically in this document, there are two levels, if I may say. One is called the lightweight certificate policy, which provides good practices for issuing any kind of certificate. And then you have another level, another policy, normalized certificate policy, which provides best practice with some enhanced requirement. And typically, if you issue a certificate with this normalized certificate policy, it will be suitable for supporting an advanced electronic signature. So it means that you have a pretty good security level for your certificates for supporting that kind of demanding signature and signature with legal value in particular. Then we had another document for specifying the issuance of certificate dedicated to issuance of European qualified certificates. This is built on the first and main document that I just presented, the 411 part 1, and this part 2 actually provides a specific certificate policy for the issuance of certificates to natural or legal person, and they are qualified. So the Q means qualified, and they can be issued to legal or natural person with or without qualified signature creation device. In this case, there are additional requirements for the management of the device and the issuance of the device, and we have a specific certificate policy for the issuance of web authentication certificates. The global level of security for those qualified certificate policy is really aligned on the normalized CP, which is defined in the part 1, but there are some additional requirements for issuance of EU qualified certificate. For example, the IDAS regulation requests that the TSP keeps the information on the revocation status even after expiration of the certificate. So this is typically something, a specific requirement that you will find in part 2, dedicated to issuance of qualified certificate. Also, in IDAS, it is requested that a certificate which is qualified according to this regulation bears the information that it is a qualified certificate. So again, you will find in this part 2 some requirement to do that, and also a reference to another European norm that I will present in a few minutes, which define the profiles for the certificate, and in particular what kind of qualified statement you can use, in particular for EU qualified certificates and beyond Europe. So this is probably something important for a part of the audience today. It is possible for any other region than Europe to build their own specification to build and to specify the issuance of certificate in their own legal framework. So if you start from part 1, which is generic, the norm 319411 part 1, you will find a specific clause, clause 7, that explains how to build a dedicated certificate policy that can fit the requirements of a local legislation. And to say so, you can also, in other parts of the world, build your own 411 part 2 for issuance of certain kind of certificate, but fitting your own regional legislation. So you will have a brother or a sister of our 319411 part 2, but for your own country. This will help also the interoperability, because they will be built on the same set of requirements at the basis, part 1, and then the additional specification for the region. Last but not least, we have a document which is presented in the form of an XLS sheet, and that provides a checklist for issuing certificate according to the norms that I've just presented. And it's interesting because you can filter the different requirements applicable in function of the CP you are aiming to observe. For example, if you want to issue a qualified certificate for legal person, which is based on a QSCD, then you can filter and you will have the list of requirements that applies to you. This is very interesting for TSP when designing the system, but also for the conformity assessment body when performing the audit. They can select the applicable requirement and check if they are fulfilled by the TSP. So it's a tool that is offered in addition to the 3 documents that I have presented. Then the next set of European norm for issuing certificate are more technical, and it's a series of 5 documents specifying certificate profiles. Here it's much more bits and bytes and technical. You will find the first part defining common data structures for certificate. It's basically based on RFC 5218. That specify formats and issuance of certificate, X509 certificate for the internet. Then you've got a second part specifying profile for certificate issued to natural person. You will find there some requirement on the structure of the distinguished name, key usage combination, for example, which kind of key usage you can use for signing certificate, or for an encryption certificate, and that kind of information. Then you've got part 3 for issuing certificates to legal persons. Basically, it builds on part 2, but adds additional indication, for example, to identify an organization, a legal person. And for example, you may use the VAT number to identify a legal person, and this is all you have to format that. Where you need to put that information in the certificate is specified in part 3. And then there is a dedicated part 4 for website authentication certificate, and this one is referring mostly to CAP Forum guideline. As you know, the CAP Forum has issued specification for the issuance of security and policy requirements, but also profile information and requests for a certificate that are publicly trusted by browsers, and also for an even higher demanding profile, which is the EV certificate, and you will find a way to do that in part 4. And lastly, there is a last part that defines the qualified QC statement that can be used, for example, to advertise the fact that a certain certificate is a EU qualified certificate, or is used in another context, in another region, for example, or to say that the certificate is for sealing or signing, or to indicate the fact that the certificate is stored on a qualified signature creation device. All these very specific statements that needs to be provided in the certificate are defined in part 5. Now, it seems complicated, but it's not that complicated. So I've here a picture that explains a bit all those norms are working together. You can see at the center of the picture, I've put the norm 319/411 part 1, providing policy and security requirements for trust service provider issuing certificate. If you are a CA, you start with this one, and you will see that it builds on the 319/401, providing general policy requirements for all trust services. So they are a reference to this 401 part, and you have to apply the different requirements from the part 401. This one, for information, and you are probably familiar with that, provides reference to ISO 27000 series for guidance, especially 27002 and 005. Then the main part for issuance of certificates, 319/411 part 1, also refers to CAP Forum, PTC and EV guidelines, and some of the requirements are mandatory from them by reference. It's also important to say that it is built on RFC 3647 that specifies a structure and a table of content for certificate policy and certificate practice statement, because you know those norms are there for years, even if in the past they had another numbers. RFC 3647 also is used since years and years by the CA community, but also by the Conformity assessment body. And this is a very classical way of presenting a practice statement and certificate policy. So we believed it was interesting for both the CA but also Conformity assessment body to have a commonly understood structure. So we use this structure to present and classify the requirement. Then the specific part for issuing a EU qualified certificate builds on the part on providing the general requirements and calls for those requirements. Both of them also require the use of the series 319/412 on certificate profile. For example, if you issue a certificate for a natural person, you need to use the certificate profile for natural person. And as I mentioned, this one also built on RFC 5218 for the specification of X509 certificates. So this is the global picture, and I will end this first presentation with a few hints or remark I found interesting to mention. There will be an update of the three norms, 401, 411 part 1 and part 2 in October this year. That kind of norm is not updated very frequently. We do not provide update every 2 weeks. So we try to have them correct as from the beginning, but of course, sometimes there are unclarities and we need to clarify, provide some correction, or also introduce new concepts to consider the trends in the market. I will provide you an example in a minute. So this is why we have an update coming in the next month. It's also important to know that all the norms I have presented right now are just providing a technical criteria in the broad sense, I mean, but you will not find any information there on how to audit the TSP. This is provided by another set of EN that are presented later on today by Mr. Fiedler. So this is really limited to the technical criteria you have to look at to design your service. As I mentioned, they are not strictly limited to a European context. It's worldwide. It can be used anywhere, and there are some tools to build additional requirements when you need to fulfill a local legislation, which is not a European one. And finally, to present you the kind of element that we bring when we update that kind of norm, you will see in the update a strong support for short-term certificates. That is to say, certificate whose validity period is shorter than the period of time, the validity period, the note between the note before and the note after in the certificate is shorter than the maximum time to process a revocation request as specified in a certificate practice statement. This is something that was not used 10 years ago, or not frequently used 10 years ago, but which is more and more used, especially by TSP offering remote signing services. They may issue a certificate on the fly, so we have provided an extension for the certificate to advertise on the fact that it is a short-term certificate, and there is no, from a policy requirement side, there is no obligation to offer a full revocation service with a call desk where your customer can call to ask a revocation, simply because you won't have the time to revoke because they are very short-term, and there is no obligation to offer both an CSP and a CRL for that kind of certificate. You need to offer one for backwards compliance, for example, to allow your customer to validate certificate with the usual algorithm validation if they are not able to interpret the short-term extension that say, well, you're not obliged to use the revocation information status service, but it is also possible to validate that kind of certificate thanks to the new extension. So this is just to provide you with an example of the kind of new elements that are introduced in the norm while we update the norms. It's time to me to give the floor to my colleague Arno Fiedler. I will provide you with additional information on banking sector related security policy.
Mm-hmm. Thank you very much, Sylvie. I think in the last hour we have learned some lessons about this, you can call it IDA's toolbox to deliver trust services. And now we have a field of application of this kind of trust services. And this is a Payment Service Directive number 2, with a key objective creating a more integrated European payments market, and especially to increase competition, making payments more secure and protecting consumers. So that's the intention of the PSD2. And let's see how they use the toolbox. Sylvie, please be so kind to click to the next slide. Thank you. I think we jumped one. Okay. So of course, we are not in the legal context, but of course, here in this Payment Service Directive number 2, we have a direct connection between an European directive and of course, IDAS and of course, the things ETSI is doing. They shall rely on qualified certificate for electronic seals or for website authentication. And so there is a clear need for a special type of transaction to use this kind of IDAS tools. And so in 2016 to 2019, it was a task from ETSI in this technical specification to define the certificate profiles and the policy requirements for open banking. So open banking means, of course, more competition and to have also new kinds of services there. And so here the seals and the website certificates are used for the identification of different payment services. So the purpose, of course, is to prove origin and authenticity of transaction between service providers. So now you have to click a few more times, Sylvie. Okay, so yeah, now you can see the things Sylvie explained to us on the right side, of course. There we have, of course, the policy requirements for open finance or open banking, how to issue the certs, of course, and especially also what are the formats for website authentication certificates or seals. So this new technical specification 19495 just combines the existing documents. Additionally, it just defines the kind of authorization number, of course. So you have a country code, you have the competent authority, it's a national authority, and an identifier for it. And of course, you have attributes for it, so payment service providers from different kinds. So it can account service payment providers, account information service providers, or for example, third-party payments providers. So there are different roles to act in this context. And of course, there are certificate fields for defining the name of the competent authority. So something like a supervisory body for this kind of services. And as Juan Carlos already told us, in 2021, we have now the JARIS digital signature that especially supports this implementation in the open finance area. So we don't call it open banking, we just call it open finance, because there are also a lot of payment industry service from non-banks. So with this set of technical specification, you can put this regulation into practice, and of course you can do it like existing building blocks. So it was not a quick win, absolutely not, but it was much easier than to define it new from the scratch. And of course, we are still optimistic that the IDAS toolset will also implement it in that way in other branches. Let's see what's happened, especially if we now get in the next days the new version of IDAS. Let's see what's it. So Sylvie, that's it in a very short run. Many thanks. I think I have a little bit more time in the next hour if we talk about audits. Thank you.
Okay, thank you very much, Arno and Sylvie. I would just like to take a 15 minutes break. So if we can start again at 20 minutes past the hour, just to give you time to grab a quick coffee or take a comfort break, and then we'll come back again after the break with my colleague Andrea Caccia and Andrea Rock and Juan Carlos, who will talk about other types of trans services supported by the ETSI standards. But let's just take a quick break, and I'll show the agenda for the rest of the day while you take a break. Back in 15 minutes at just after 20 minutes past the hour. I'd like to pass on to the presenter on the other application standards slide. I'll give you the control once I've sorted out this technology, Juan Carlos. So over to you, Juan Carlos.
Perfect. Then, okay. Now I think that you should see my screen now.
Yes, we can see it. Thank you.
Okay, perfect. Just leave me 1 moment. Okay, this presentation. In this presentation, we are going to talk of two types of very relevant services, namely the electronic registered delivery service and one of its types, which is the registered email service and preservation services. Okay, this is the agenda for the first part of the presentation, and this is the agenda for the second part. I think that, well, I will quickly go through these slides. The first part, as I said, it will consist in presenting some brief concepts on electronic registered delivery service and its relationship with registered electronic mail service. Let's start with a quick definition. As the electronic registered delivery service is an electronic service that transmits data between senders and recipients by electronic means, and provides an evidence relating to the handling of the transmitted data, including proof of sending and receiving data. So in addition to offer the capability of transmitting data, one of the crucial features of this type of services is that they provide evidence that certain facts have occurred during the transmission of the data. And these proofs can be used later on in case of dispute or for proving things. Finally, it also protects the transmit data against the risk of loss, theft, damage, or alterations which have not been authorized. The registered electronic mail service is an instantiation of the electronic registered delivery services, which are built on the stack of protocols for electronic mail. So in such a way that we consider a registered electronic mail service, REM service, as a special type of ERDS of the more general concept of electronic registered delivery service. The next picture, this picture shows the stack of standards that ETSI has produced for dealing with both with the electronic registered delivery service and registered electronic mail. As you can see, there is a stack dealing with policy and security requirements, and I will talk about that later on. There is also a stack on protocols and bindings, and finally, there is another stack for conformance and interoperability testing, and interoperability testing. And you can see that there are two documents in each stack. One for the more general concept of electronic registered delivery service, and another more specific for registered electronic mail. But both of them, all these stacks built on what we call the pure e-delivery services, meaning those services which allows transmission of data with certain reliable transmission of data, but which are not entitled to provide evidence of the crucial facts that have occurred during the transmission of the data. Okay, let's start with the different stacks. Let's start with the policy documents, and we must start with an assertion that not any electronic delivery service provider is a provider of an electronic registered delivery service, as I already mentioned it. For being considered an electronic registered delivery service provider, this provider must fulfill the requirements defined in this specification, in this standard, the 319521. Those ones that those providers that want to be entitled or qualified as REM providers must fulfill the requirements specified in this other set. But the crucial thing is that any electronic delivery service that fulfills this specification is an electronic registered delivery service, and any electronic mail provider which fulfills the requirements provided in 319531 is a registered electronic mail service provider. Okay. Regardless the technicalities in terms of formats and protocols used, it's evident that a REM provider will use always the electronic mail set of protocols, but this is not initially true. I mean, in general, an electronic registered delivery service can use other different protocols and stacks based on web. These policy documents define requirements for the general provision of policies and practices, like service provider practice statement, terms and conditions. It also specifies provisions for the services, like integrity, confidentiality, time reference, evidence interoperability, rules for doing risk assessment, and also about the management and the internal management and internal operation on the provider itself, like the internal organization, how to organize the human resources, asset management, etc., etc., etc. These are basically the most relevant parts for doing which specify these documents. So, and then I emphasize once again, any provider that fulfills these documents must be considered either a REM service provider or an electronic registered delivery service. And in the case of the electronic registered delivery service, regardless the protocols used and the data used for transferring information, as long as they fulfill all the requirements of this 319521, they are electronic registered delivery service. Then, now, why do we have the rest of the specifications? The rest of the specifications, the 522, the 532, the 524, and the 534, are there for facilitating interoperability among providers. This is the main goals of these other two stacks, facilitating interoperability. And for doing that, the 522 is both of them, 522 and 532, are multi-part document. In the part one, it defines different models. The black box model, which corresponds to the situation when the same provider serves the sender of the message and the purported recipient of the message. What we call the four corner, where there are one sender of the message and one recipient of the message, but both of them are served by different providers, which must then exchange message between them, and the extended message, where the provider serving the sender and the provider serving the recipient do not exchange directly message among them, but they need other intermediary providers in the path. This part one also specifies which are the relevant events for which we will need evidence. Okay, and then there are a number of events and the corresponding evidence, like the acceptance by the provider to process the message that the sender, the subscriber, has sent, and the acceptance of the recipients of the ERDS, the ERDS of the recipient to accept the message coming from the origin, etc., etc., etc. Okay. The important thing is that this list also includes evidence for situations where some entity, either the recipient or one of the providers, rejects to carry out a certain action, and then it may provide an evidence of that rejection, or situations where there are failures. The good thing, there is another remark, which is that those the evidence set is common for both for the REM and for the ERDS, because REM in the end is a specific instantiation of ERDS. If somehow this sequence diagram would show how things could go in a specific instantiation of interactions between the subscribers, which are the sender and the recipient, and the providers, with the help of a set of tools that we call common infrastructure, which helps providers to communicate among them and to rely on them. So in this situation, a sender would identify himself and authenticate himself or herself before the provider, and then sender would submit the message, and this provider would generate an evidence of acceptance of submission of the message to the recipient. After that, based on the address of the recipient, it would look in the common infrastructure. Well, it would look for the provider giving service to that recipient, would get its coordinates, and then there would be a handshake between this recipient and the provider of the recipient, in order to ascertain whether the sender is really may be relied. And after that handshake would take place the relay of the message from the provider of the server to the provider of the recipient. And after that, the ERDS the provider of the recipient would notify the recipient that there is some message for that recipient, and after the acceptance of the recipient for getting access to this message, the provider would leave the message within its own premises in a place which is accessible to the recipient. That fact is called consignment. The message has not arrived yet to the recipient, but it's in a place within the boundaries of the service to which the recipient can access. After that, the provider of the recipient would generate the evidence that the consignment has taken place, and this is a crucial fact as well. And finally, the recipient could identify and authenticate before the provider of the recipient and get access to the message. And this fact, I mean, make that the message which was within the boundaries of the service is now in his hands or her hands, out of the boundaries of the provider. And this action is called handover. And this would be a typical scenario of exchanges between recipient, provider of the recipient, the common infrastructure, the recipient, the provider of the recipient, and the provider of, and the recipient herself. Well, obviously there would be a handover. In addition, this technical, the 522 defines in addition to this fact, it defines message bindings for messages protocols. I mean, I already mentioned it that an ERDS is any service that it's able to that fulfills the requirement in 319521. But I said that these technical specifications were there for the sake of interoperability, and these specifications selected the AS4 profile of EBMS 3.0 as one of as the good candidate for defining a binding in terms of semantics of the data that flow between the different providers, the formats for the evidence and other components which defines the EBMS and further profiles the AS4, and finally bindings for them. Okay, these are the three parts. Finally, the 319524 is a technical specification that helps testing conformance of the applications in terms of testing the conformance of the evidence set that the certain tool generates, etc., and interoperability. And this part defines a number of test cases for testing interoperability between two providers. In 532, things are more or less mimicked. Okay, again, it's a multi-part document. Part one defines the same three models, which one specific addition, distinction between store and forward and store and notify, and you may find the details there. And it also defines the same set, a similar set of evidence. And but the main difference is that this document defines the binding for electronic mail standards, whereas the 522 defined a binding for AS4. And in that way, part two defines the semantics, again, of the data that flow between the providers. And part three now defines MIME structures for the messages that must flow between the providers, because the formats of the evidence are exactly the same as in 5.2, in the set of 5.2.2. And also defines interoperability profile. Well, the latest update of part 4 includes a definition, the specification of what we call a REM baseline, which is something that about which my colleague Andrea Caccia will tell you in the next slides. And finally, the 532 is again a technical specification for testing conformance and interoperability, but in the world of registered electronic mail. Now I will pass the hand to my colleague Andrea Caccia, so that he will present.
Thank you, Juan Carlos. Can you hear me? Can you switch the slide for me so that we avoid?
Yes, sure.
Thank you.
Just tell me when I click.
Yeah, so Andrea Caccia from Small Business Standards, that is an association that represents the interest of small and medium enterprises in standard developing organizations like ETSI. So let's continue with the concept of REM baseline. REM standards include many features that are very flexible to support the different business requirements, but this, of course, can become an obstacle for interoperability. And so, and also to define a common and appropriate trust level between the systems. So, if you can continue.
Yeah.
Okay. So the issue that the REM baseline aim to solve is to support mutual recognition, trust, and interoperability between different REM service domains. For example, between different countries and different jurisdictions. This is something that is very relevant for the workshop today, because indeed is a sort of is a baseline a set of part of the standard that allow to ensure full interoperability and ensure the recognition, mutual recognition and trust. And again, another issue that is addressed is to support basic common trusted delivery service requirement, enabling the provision of broad number of services. So this means that, of course, if you have some basic features that are guaranteed between a number of trust services, then you can achieve to have some basic service can be provided in an interoperable way. And this is often a requirement for the public sector, because the public sector typically has a number of platforms, like for justice, for many different kind of requirements, where a common trust is really key, because you have a basic trustworthy infrastructure that can support those platforms. Yeah, we can continue. So the issues that is handled by the REM baseline is to have a technical specification that profiles and augment when needed the REM interoperability profiles that are currently published as PAS 4 to ensure indeed the maximum interoperability and qualified grade trust across the REM service domains. Okay, let's continue. So REM baseline then fully addresses two main points. So the requirement to secure the proof of sending and receiving the data, leveraging on other trust services, namely the electronic seal and or signature and the timestamp. So reuse as a building blocks the already defined services in a way that can protect the important events that has been highlighted as part of the electronic delivery services. Then the specification of a common service interface in REM messaging that guarantee the trusted interconnection between the REM service providers and a common trust framework. Okay, so the benefit for the providers is that a baseline trust and interoperability is provided that help to have, on one hand, to spread the use of the service, because having some basic features that are available from all the providers, of course, help to spread the use of the service. But on the other hand, allow for every single provider to add value and add maybe some to enable competition, but or to have also the possibility to add features that became another value for everyone. Yeah, you can continue, please. So now as I said, as Juan Carlos said, the REM baseline standard is already available for testing, is fully implementable, and ETSI started yesterday a plug test that is an event where interoperability is tested between different solution providers, with different providers. And ETSI indeed has a specific organization that is named Center for Testing and Interoperability that organizes 2 times per year, typically, plug tests on signature formats or signature verification, and now also on REM, and in future also all the other ERDSs. The plug test is a unique opportunity for implementers to get together with peers and test interoperability in a neutral environment, and also an opportunity for ETSI to improve the quality of standards, because typically during the plug test, maybe different interpretation mean different, we can say, interpretations that are legal according to the test from different providers that bring to lack of interoperability are detected, and the text of the standard can be improved in this. Okay, so some few words about how this test is conducted. We have identified 4 type of tests. One is a generation and cross-verification of evidences. As said, ERDS evidence are in common between RAM and general delivery services, registered delivery services. Then we have a specific test for messages, so for RAM dispatches and RAM receipts. So the MIME, we can say, content of the messages. And then we have a real-life test between RAM protocols, so two different providers that interact together, and also a fourth type where they do not interact together directly, but they define a specific means. So this is a test-only way to interact, but is useful when providers are not able to, in a test environment, to connect each other in a real-life test. Here is the link to see some additional information about this plug test. It is still possible to register if you want to participate, but just as observers, because of course the platform has been generated according to the actual participant. But I think it could be a useful tool to understand more on RAM and on RAM baseline in particular. Thank you, and now I give the floor to Andrea Rock for the preservation part of this presentation.
Hello. So I will give a small overview on the documents linked to preservation service. First, explain a bit what we mean by preservation service within ETSI. What are the differences between the archival service? Describe the main modules we cover in our standard, and then the different documents really related. So for preservation service, within our ETSI standards, there are two possible goals for them. But what is important, in both cases, they're always achieved using digital signature techniques, meaning that using something else would not fall into the scope of this document. The first goal is extending the validity status of a digital signature over long periods of time. What does this mean? It's not sufficient to just give a proof of existence or keeping the signed data and the signature, but what is also needed is the all the data for which is needed to validate the signature, because otherwise we have, if this data is not there anymore, we have no possibility to say if the signature at a specific moment in time was valid or not. This is something that's important. The next goal is providing a proof of existence of data over long periods of time. So this is a bit different here. We just talk about the pure data. And what the problem we struggled when writing this standard was that there are many different cases how this can follow. There are many different techniques. So it was a bit a challenge to find a formulation that can cover most of them or as much as possible. So there's a big confusion between archival service and preservation service. So I try to give here some examples how they relate and how they are different. An archival service may use digital signature techniques to provide a proof of existence, but in our case, it has to be a preservation service, as defined in ETSI, always needs to use digital signature techniques. An archival service without a preservation service does not capture nor verify any validation data associated with the digital signature. It just gets the document and will store it like this, but it does not care about validation data. An archival service can use a preservation service to provide proof of existence of data based on digital signature techniques. However, the preservation service just cares about the main data, the main file. The archival service, in addition, would need to manage metadata required by the archival service. There's an example of such metadata is archival information package as defined in the Open Archival Information System reference model. And a preservation service without storage, with storage, sorry, can use an archival service for the goal of storing data. This is kind of a link in the other way around. And what's also important, the preservation service, as defined in ETSI, never transforms the original data. So it's not for the archival of 100 years that you think, okay, a format might not be used and readable anymore, and we change the format. No, preservation service just take the data and keep it like this. It will not transform it. So we have introduced 3 different models of or use cases of preservation services. The first one is with storage. The idea is the client provides the data, the preservation protocol, and the preservation service stores the submitted data object and also associated preservation evidence locally in its storage. During the time of preservation, it probably uses other services like requests to see CAs for the revocation information, to TSA, a validation service and things like that. Part of it might be also internal. And it has 2 important elements, which is the monitoring, which kind of the role of the monitoring is to check when do we have to do something, which are the algorithms that are still strong enough, are there any certificates that are going to expire. This is the monitoring part. And the augmentation part is I will change something, I will add additional evidence, for example, revocation information, certificates, and protect this with a timestamp. So this will be done in the augmentation part. So for the preservation service with storage, the objects and the evidences are stored. They are delivered to the client upon request. And if needed, the evidence are augmented by the augmentation service. The next use case or model is a preservation service with temporary storage. The idea here is that data is provided through the data to be preserved or signature to be preserved are sent to the preservation service. And it will keep it for some time, but not for a long time. An example of such a service is, for example, a service that receives data during the whole day and will create the evidence only at the end of the day. So this service keeps the data or the hash of the data only until the evidence is produced, and then allows the client for some time to get this evidence. So the evidence are produced asynchronously and are retrievable for a limited amount of time. And then the last case of the preservation service is a preservation service without storage. And here the thing is, it works synchronously. I send my data to the service and it will create preservation evidence and send it back. This evidence will allow to augment the time until when a signature can be verified. But yeah, it does not store anything itself. It just give it directly back. And within ETSI, there are 2 documents covering preservation standards, preservation services. The first one is the TS 119-511. It's policy and security requirements for trust services, providers providing long-term preservation of digital signatures or general data using digital signature techniques. So those are the rules a service wanting to have propose such a service have to follow. The second document is the TS 119-512, which is a protocol document. This means it proposes a protocol how to talk to a preservation service. And there are 2, again, like often we have kind of first, at one hand, the syntax, the functionality we want to have. Then we have 2 implementation, the JSON one and an XML version of this. And yeah, that was all. Very short introduction to the document on preservation.
Thank you, Andrea, and everyone. So I'd like to pass on straight away to the next topic, which is presented by my colleague Arno Fiedler on auditing and supervision and certification. So over to you, Arno.
Yeah, thank you very much, Nick. So let's share the screen. I think you can't see the screen now. I just see me. Oh, yeah. Just a second. Sorry for the delay, but I lost the access to the dashboard here.
Yeah, we can see the editing view of the slides. If you just want
Okay,
to
you can see the editing. Okay, I was not able to see the view by my own. So okay, so you can see the slide now.
That's better. That's
okay.
Fine.
Thank you very much. Yeah, I think we have to hurry up a little bit, but I think of course, the supervision, certification, and audit is a very important point. And of course, within IDAS Chapter 3, so we are not talking about the notification for identification service under national laws. So that's Chapter 2. We are here within Chapter 3. And of course, there we have also a quite sophisticated, audit regime, or can call it audit or supervision framework. And the source of this picture, this was a study, a Square study from 2012. So it's really, yes, a long time development to get things up and now hopefully quite ready and also reliable. So at the bottom of the pyramid, of course, we have here best practice and standards. That was what we talked about the last 2 hours, of course. So for example, the ETSI standard, but also others, of course. Then, of course, we have the direct provisions for qualified trust service providers from IDAS, like Article 24 or others. And here, of course, in the inner circle, you have this regime. So you have a quite well-defined process of initiation of services and finally also termination of services. But of course, we have a good procedure for regular assessments. And of course, if you finally manage it to fulfill all the requirements as trust service provider, of course, you granted access to the trusted list. And finally, you can use as a qualified trust service provider this wonderful new brand. So yeah. Okay. So what is the principle, the audit framework? You have national trust service provider assessment schemes. That means the dotted line here. You have schemes operated, of course, in Italy, in Spain, in Germany, France, or other countries of the United Union. But of course, the principle for trust service under Chapter 3 are always the same. Here, of course, we have the less important role that the trust service provider. And this trust service provider has, of course, to fulfill some assessment criteria, and he has to deal with a conformity assessment body. Of course, we can call it audit body, but the formal wording is conformity assessment body. It's a CAB. And of course, he's working with assessors, but it works a little bit other than in other trust schemes like Web Trust. It's not about the individual auditor or assessor. It's always a complete system, complete company working as conformity assessment body. And this CAB has to be confirmed by a national accreditation body. For example, in Germany, the DAX. And of course, in best case, all national accreditation bodies work together within the framework of the European accreditation. So there's a cooperation for the national accreditation bodies qualifying the conformity assessment bodies. To make the things not too easy, of course, we are here in Europe, of course, we have, of course, another instance, that's a supervisory body. This is also defined by national law, and this body is responsible for taking a closer look to the assessment reports and, of course, granting access to the trusted list. That is the infrastructure. And now here is a quite good picture from a new publication from ENISA. And here you have the process flow for the qualified trust service and the supervision process flow. You have a national accreditation body working on a defined accreditation base. This national accreditation body, of course, accredits the conformity assessment body. This conformity assessment body has to work on a specific assessment scheme. And of course, the CAB assesses the qualified trust service provider and produce a conformity assessment report, a CRR. So of course, the QTSP has all to do a lot of things. Of course, we know, many of you know how complex it is. Of course, they have to design their product in a specific way. They have to do testing. They have to do some documentation. And of course, they have to convince the conformity audit body that all the requirements are fulfilled. And then, of course, in the next step, the conformity assessment report is sent to the SB, the supervisory body. And of course, there's a compliance verification. And if the qualified status is granted, of course, you can take part within the trusted list. So the status of the CAs is, of course, part of the trusted list. But I think Olivier will a little bit later tell us a few things about trusted list. So the framework from ETSI to do this kind of audits according to IDAS, that's 319.403.1. Of course, it's a little bit torturing by numbers, but it's important. It's not the 401, that's a policy, or the 411, that's also a policy. That's a 403. And since, I think, 2 years, we have not only one document, we have a set of documents. The main document is the 431, and it's not an invention by the ETSI ESI team. It's, of course, based on ISO 70065. So it's really nearby to this international norm specifying general requirements for conformity assessment body. And of course, it's not only for the specific for the certification of products. There are, of course, other audit standards or audit requirements. It's more focused on processes and services, especially trust services. What's also important is that it incorporates additional requirements on the certification audit bodies as defined in ISO 20021. So it's a quite complex set of rules to conducting the audits under the scheme. Then, of course, we have new supplements on additional requirements. One is a specific part for publicly trusted certificates that's dealing with the requirements from CA Browser Forum and getting acceptance by our beloved browsers, of course. So there are specific requirements. It's in part 2 for publicly trusted. And this document is done in very close and very successful cooperation with AGAP-C, the Council of the Certification Audit Bodies. And then, of course, we have part 3, that's a specific part for the audit against the IDAS regulation. Okay, just a few major points about the audit report should provide it every 2 years at minimum. If there are major changes, for example, of the PKI systems or other main important points, a full audit is required again. And of course, the audit has to deliver evidence that the specific IDAS requirements are fulfilled 19, 24, 28. It should follow best practice, but of course, it's important to mention the ETSI standards are not mandatory, but they are, of course, best practice. And there is a need for the communication with the SB. Yeah, what is the process of the audit, of course? In the first step, of course, the stage 1 audit, you have this document assessment. So the auditors will check the complete set of documents about technical, functional, organizational security measures, and of course matches with their own interpretation of the IDAS requirements. So that's a document assessment, we call it stage 1. Then, of course, even in times of Corona, there is an on-site assessment, can call it stage 2. So you make the verification, the implementation of the security measures, and of course, there's a technical and also penetration testing is part of this. And as a result, of course, we have the conformity assessment report. Here's a very complex picture. It's also from the new publication from ENISA, Assessment of Qualified Trust Service Providers. And here you can see all the steps that has to be done in the preparation and also in the document assessment. I don't want to tell it in detail, but of course you have to have a lot of plans. It's, for example, business continuity planning, it's a disaster recovery planning, and a termination plan. So I think it's always a little bit funny if you start before you take up your business as qualified trust service provider, you have to finalize the termination plan. But of course, that's of course how the game is played, and of course it's of course also for data protection reason to know how to terminate qualified services and deliver evidence for long term and things like that. Here in the on-site assessment, of course, it's also important point is here in the middle to have to deliver evidence, and the logs are reviewed, and of course there's a lot of sampling and testing, and of course then there will be a decision here with a green point, you have passed or you have not passed, and then finally you get the certification report. Here's a slide from Christoph Sutter from the CA Day 5 years ago, and it's about the typical timelines to become a trust service provider. In this case, it should also be for the qualified trust service provider. So in the new normal case, you need a minimum 1 year for it. So 6 months for the preparation, 3 months for stage 1 and stage 2, and of course a defined time for the supervision body to check the documents. So if it's just a reassessment of a qualified trust service provider, you can do it quite faster. That's case number 4. So maybe it's about 1 month. But to become a TSP, it's in a normal case, it's 1 year. And of course, the minimum is 9 months to do it. So that should be taken into account. Okay, and here's the final picture of my presentation. I know it's a big picture, but I just try to put everything in. So we have a complete tool set for auditing trust service. And of course, you can see here, and identification, because we had a lot of discussions about how to make audits in this case. Sylvie and all the friends in the team doing a very great job to put these things also in this framework. So here we have, of course, the main document, the 403, about the conformity assessment. Here we have the documents with additional requirements for specific case, for example, publicly trusted. Then, of course, here we have the certification policy, the general policy with all the basis requirement from IDAS, and you can also use this document in context of ISO 27000. Then, of course, we have the more specific trust services here in the 411.1, also with requirements from IDAS and CAP Forum. And then, of course, here finally, as Sylvie told us, we have the documents for qualified trust service. And this is in a complete framework. And I think it's important to mention that there's also a checklist with a list of all controls. I think it's around 540s, and of course, it's really a good job to update it always. So yeah, thanks to the colleague who doing this. Okay, that was a very quick run. I know it's a complex matter, but I think we run a little bit out of time. Thank you.
Thank you very much, Arno. I'd like to pass on next to Sylvie, who's coming back to talk to us about identity proofing. So I'm passing you the screen, Sylvie, if you can show your presentation and your camera.
Yes.
Thank you.
Hello again. So this time I will present you the set of standards for identity proofing. So this is actually developed within a special task force whose name is 588. Don't ask me why, but the important is to present you the rationale for this special task force on identity proofing. We have presented to you a lot of different technical specification and European norms published by ETSI on trust service, and most of them are actually already specifying identity proofing, but very lightly, if I may say, and using the vocabulary like physical presence or by means which provide equivalent to physical presence. This is a wording which is derived from the EIDAS regulation. And the problem is that today physical presence as a benchmark is not well defined. There are no real requirements. You can look on the different specifications on the market all over the world to explain how to perform an identity proofing with physical presence of the applicant. So it's difficult to assess what can be equivalent to assurance, a remote identity proofing, for example, with the same level of assurance as a physical presence, because physical presence itself is still subjective and really nowhere defined. And it's a problem because if we have no guidance for physical presence identity proofing, but also remote identity proofing, the fallback scenario for trust service provider is to always come back to physical presence because they are not able to prove that a certain identity proofing with remote process can be equivalent to physical presence. So there is definitely a need for guideline on identity proofing, physical presence, but also remote, and find a way to provide specification for the different context with the aim to achieve the same level of security and assurance in the end of the process. Another element is that many trust service providers is issuing a certificate or timestamp, or no, it's not a good example, they are not subject to register, but a remote signature, for example, tend to outsource the identity proofing process to dedicated service providers. And this discussion is even more important today, as you know, within the EIDAS regulation update that may potentially put more focus or importance to e-identification. So all those reasons makes that it was important to start specifying identity proofing. And actually we have developed a technical report and we are on the point to issue a technical specification. This is the two documents that are produced by this special task force. The technical report actually is a survey of all technologies, legislation, specification, guidelines, and standards related to or used for identity proofing. So we collected information from different stakeholders, such as national agency developing requirements, product and service vendors, TSP, academic environment, and of course existing specifications. There are more specification in the US. NIST has done a lot for that, for example. So we look at documentation everywhere, all over the world. This one has been published. I will provide you the link to it. It's on the ETSI portal in the beginning of this year. And it also serves for us as a source of finding interesting requirement to specify the second document, which is policy and security requirements for trust service component, providing identity proofing of trust service subjects. And so the document we are developing can be used for conformity assessment of a trust service provider, which includes this identity proofing component within his range of service or component, or the TSP that can hire a specialized company providing identity proofing as core business to different customer and different trust service providers. The idea of this document is to provide specification for different scenario or use case, like physical, or remote with video, or purely automatized based on electronic identification means. All of them aiming to offer a consistent outcome level that we have called baseline. In other words, best practices. It's also important to remind that identity proofing is not an eIDAS trust service by itself. It's a service, but it's always a component of a service. Would it be a trust service, but also beyond, like a component of a bank that needs to perform a KYC process, but it's not identified in eIDAS today as a trust service per se. So it's interesting, especially if an organization perform identity proofing as core business, to be audited once and reuse the audit for the different customer. And in particular, if it offers the service to many TSPs, this audit can serve the audit TSP at the level of the trust service that is performed by the auditor on the customer trust service provider. The security and policy requirements that we provide are first for the common requirement based on the norm EN 319401 that I have presented this morning, which provides all the general requirements for trust services in terms of HR, network, building, security, and things like that. Then we have specific requirement for identity proofing. We have a clause which is dedicated to best practice on how to use or to design a list of selected means that are classically used for identity proofing. So in a nutshell, you can use a video interview, that's a kind of mean. You can also use a digital signature made by the applicant, and by looking in the information in the certificate, you can have proof of the identity. You can also use an e-identification means. So that's our example of means that we specify in a dedicated clause of the technical specification. And then, and this is probably the most important, there is a clause dedicated to the combination of those means, one or two at the same time, for the different context, as I said, with the physical presence of the applicant, or with a video, or by purely automatized tools using EID, for example. We explain how to combine the different means in order to, in fine, at the end of the process, have this baseline level, this best practice, with the same level of security for all the different use cases. Of course, the aim is to provide guidance for existing norm that has been presented, like, for example, 319411-1 for issuance of certificate. You've got there clause 6.2 that explain how to register an applicant. Again, with very generic terms like you need to have physical presentation or equivalent. If you want to, if you are TSP and you want to have ID to design your identity proofing process in more details, you can then use this TS 119.461 to have more concrete and measurable controls and security requirements. And of course, it aims also to support the registration of applicants for qualified trust service, and in particular for the issuance of qualified certificate. As it has been said previously, in the eIDAS regulation, there is an article which is dedicated to identity proofing for issuance of qualified certificate, and this technical specification aims to provide the requirement to fulfill with this article, which is 24.1. So actually, how did we select the requirements? The idea is to circumvent the commonly faced risks by organizations doing identity proofing. The risks are falling into two main categories: falsified evidence, meaning you've got someone in front of you that claims another identity by using forged evidence. So that he made by himself, that he took a photocopy of an ID card and put his name on top of it and things like that. Another issue is identity theft. So you've got an applicant with genuine evidence of his identity, a good identity card, for example, but stolen from another person. We also consider operational risk by reference to the norm 319401, all the risk by, on, for example, the security of your buildings, network, etc., and social risk, because it's also possible that you have the right person with the right document, but constrained by someone to perform the registration to a trust service. This is the objective is to have good practice, best practices. So we do not have low-level identity proofing use case, but we do not have either high-level, for example, that would be for military purpose or even for issuance of a national identity card. This is perceived as a bit too constraining for trust services. We really want to provide best practice suitable for the different trust services as defined in the IDAS and specified in the other ETSI specification that has been presented previously this morning. So what is identity proofing? As I said, it's part of the broader identity management life cycle, and it's always to be considered in context. So whose identity? Classically, natural or legal person, or a natural person representing a legal person, but you can also identity proof a device. What kind of attribute for those person, for a natural person, for example, you have to check the first name, last name, a minimal set of information that allows to uniquely identify the person in your context. But you may also identity proof other attributes like a profession, for example. For what purpose? There are many cases where identity proofing is needed. As I mentioned, it can be in the framework of KYC for the bank when a customer wants to become a new customer of the bank. And I provide other example over there. But in our case, the focus of the work is EIDAS, trust services, and enrollment of subject for those services, like issuance of certificate, registration to a registered email, or to a remote signature service. And for each context, you have driving requirement, and in our case, it is the IDAS regulation chapter 3 that is providing the requirement for identity proofing. Typical output, as I said, it depends, of course, on the context. It can be the issuance of a certificate. It can be, in another context, the issuance of an EID means. So what is identity proofing? It's typically defined as 3 main steps: collection of attributes, then validation of the evidence that you use to collect the attribute, typically the identity card, and last but not least, the mapping with the applicant. You need to check that the person which asks you for being identity proofed is indeed the right owner of the evidence that are presented. Before you have some step for the initialization of the service, warning the person of his rights and how the system is working. And at the end, you need to produce a result, which can be the identity of the person that you are going to transfer to your customer. That can be a TSP, for example, that needs the identity to issue a certificate. And so the TS we are specifying is really about the green box that you see above, and it's specifying this process. I will provide a bit more detail in a minute with example of what kind of element we are specifying. To come back on the survey, very briefly, you will find it on the ETSI portal. We have analyzed 53 sources of information. It's actually a lot because some of those sources were made of, it was, for example, a series of norms. So sometimes it's 5 or 6 documents for one source. And we collected them within ETSI, but also via emails to different stakeholders. We had a liaison with ENISA, that was also working on a companion study, if I may say, on remote identity proofing. I will provide you also the link for this study that has been published 1 month ago. And we also produced questionnaire. We had 14 answers. It may look not that much, but they were really in depth, and we learned a lot from vendors of identity proofing product, but also trust service provider and qualified trust service provider. That was very interesting to learn the difficulties they face for identity proof the customer. And of course, we look at the EIDAS update consultation. There was a public consultation where different stakeholders could provide their feedback for the EIDAS update, and that was public and also a very interesting source of information for us. I will skip. This is the methodology we used for producing this year. Basically, we had a reading sheet to provide the common windows to look at all the different sources of information, actually based on the different steps of identity proofing to be able to compare. But I need to maybe pass more time on the technical specification, which are the actual aim of the special task force. So you will find in this document technical specification on attribute and evidence collection, what kind of attributes are needed according to the entity that you have to identity proof, the type of evidence that can be presented, for example, ID documents or EID means, or a digital signature on the basis of a good quality certificate. We also specify the presentation mode, actually shown on a screen or provided in a hand-to-hand directly. Maybe a copy of a card can be produced, or evidence can also be transmitted purely in a digital form, extracted, for example, from an EID document. We specify the communication channel. Of course, when you perform a video interview of someone, and especially if it is unattended, you need to be sure that there is no man in the middle and no interruption in the middle of the process. Attribute and evidence validation. This is all the specification on how to validate that ID attributes are valid, typically not expired, not revoked. It's different from document to document or from means to means. Determination that the evidence is genuine. This is specifically important for official document, passport, ID card. You know, you've got different things like hologram that can be and that should be, when they are present, validated. And this is what we specify in the clause attribute and evidence validation. When they are applicable standard for validating certain kind of identity documents, we refer to them in order to not reinvent the wheel. Maybe the most important part of the identity proofing process, the binding with the applicant, which is the step taken to confirm with a given degree of confidence that the claimed identity credential which have been obtained and confirmed valid are indeed those of the applicant and not someone else. To do that, we have identified 4 use cases face-to-face. So you've got the claimant, the applicant in the same physical environment as the registration officer. Attended video, meaning I have an interview with a real registration officer in front of me at the other side of the video, or unattended, because there are methods today to with our AI to be able to detect if the person is alive, if it's not a video of a person, if the piece of identity are genuine, etc. And then the use case purely digital use of EID means or electronic seal or signature. We also specify in some cases access to secondary trusted source of information when you want to confirm something that you have checked with one of the other use cases. So it's also important to mention the fact that in most of the case, the use cases are hybrid. You can mix remote, attended and unattended, or face-to-face and digital, etc. So, as I mentioned already, the important added value of this specification is probably the way to combine those different means into a consistent level of identity proofing process, independently of the different use cases that are presented. So means and technology combination that can be that are eligible to be considered to reach comparable confidence in the identity proofing outcome, are specified by requiring fulfillment of general best practice requirement for the identity proofing process as considered suitable for the different trust service policies that has been defined in ETSI. The level of risk that can be circumvented is called moderate. So as I said, it's not for low-level identity proofing, but it's not also for military purpose. And to correctly map this with the other ETSI specification that we presented previously today, we have an annex that that really maps the different requirements in the technical specification with the other ETSI technical specification. For example, we have a specific annex to explain how the identity proofing requirement developed in the technical specification can fulfill the requirement of issuance of normalized certificates as defined in the norm 319/411 part 1, also for the issuance of qualified certificate as specified in the norm 319/411 part 2, or you can use them and how they fulfill the requirements of ETSI EN 319/521 for registered delivery services that was also presented to you previously, and for remote signature service that are specified in ETSI 119/431-1 and also by reference to another important specification, CEN EN 419/241-1. And then finally, Annex B is presenting the typical attack scenario and risks that you can face when you have to perform an identity proofing process. This is not done. This is a process still. This is the last thing we have to develop in this document. And we will identify for each presented attack scenario if it is covered or not by the technical specification. And this will help the trust service provider that will rely on an identity proofing service conformant to RTS to assess whether the attack scenarios that are that he faces are correctly covered by our technical specification, and if our technical specification are a good benchmark for the design of the identity proofing process. So this is my last slide with a few links to interesting documentation and an information on the date of publication of this TS. It's scheduled for the second half of this year. So we are almost at the end, but it's not totally finished. You will find information on the project on the ETSI portal. And if you're interested in the topic, you can also look at the portal of ENISA. They have published the analysis of methods to carry out identity proofing remotely. And in general, you will find in our technical report a lot of reference to different specification, guidance, legislation, as I said, from all over the world. So this is it for identity proofing. And right. I guess I can give back the floor.
Thank you, Sylvie. There was one very difficult question that was asked, which I perhaps have a go at, and then you can give your view, as how it relates to the 1502 regulation for electronic identities, and whether it maps to substantial high, which has been a tricky issue from the beginning, and we spent quite a last meeting discussing this. If I just give my sort of view on this, and then you can come in. My view is that if you go back to your slide 11, we cover lots of different use cases. One of the use cases is using electronic IDs. So you've got at the bottom, one way to prove your identity is use an electronic identity. That electronic identity may be substantial or high, but substantial is considered sufficient. We don't map all the other use cases to any part the 1502 level, because that's outside our scope, but they are aiming for sort of equivalent levels. So you can draw your own conclusions from that, but we can't say it is substantial or high, but we can say one of the use cases uses a substantial EID as a means of doing identity proofing. You can draw your own conclusions from that. Anything further you want to add to that, Sylvie?
No, I agree. So it's important to remind that the scope of this technical specification is not specification of identity proofing for EIDAS Chapter 2. So we are not specifying how to issue an EIDAS EID means of level substantial or high. It's really specifying identity proofing for trust service. And as you know, in EIDAS Chapter 3 on trust service, there is no that kind of classification, low, substantial, or high. A trust service is of a good quality, can be qualified, that can be seen as a sort of classification, but usually the level for non-qualified is almost the same as qualified. So in this case, it's ready for trust service. However, it's, as you said, Nick, and I maybe use other terms to further reinforce what you say, we rely on EIDAS EID means in our identity proofing process based on use of EID. And this is normal and important because the sole link between EIDAS Chapter 2 EID means and EIDAS Chapter 3 Trust Services is Article 24 for issuance of qualified certificate, and there you see that it is possible to use EIDAS EID means of level substantial or high, provided there was a face-to-face to issue it previously, to issue a qualified certificate. And here our technical specification, Annex A, where we say how to use the different requirements for issuance of a qualified certificate, we clearly say that you can use an EIDAS EID means of level substantial or high with a previous face-to-face. This is the sole straight link between EIDAS Chapter 2 and Chapter 3, and the sole way it appears in our technical specification. Now, to conclude, and I will finish, I can say it orally, it's not written in the document, but of course, EIDAS 1502 provides very good guidance for identity proofing in the first clauses. And we can claim, I think, that the specification we provide are at least fulfilling the level substantial, but there is, it's just for your indication. We do not specify EIDAS EID means, but we know 1502, and we know that the level of security we provide is at least equivalent to substantial.
Thank you. Thank you very much. So we're running a bit late, but I want to still give you another 15-minute break because I think it's been fairly intense, lots of numbers and lots of information. I'd like to give you 15 minutes break, so if you can come back to 15 minutes to the hour, and then I'd like to pass on to Andrea Rock to say a bit about remote signing, which is one of the biggest ways of supporting signing. Then ask Olivier to talk about trusted list, mutual recognition, and hopefully we will have sort of 20 minutes or so towards the end it's to closing remarks, and there's a couple of questions that people have raised. If you've got other questions, please put them in the questions tool, and we will try and answer them either at the end of the meeting or after the meeting. Right, so reconvene at 5:02 ER. Thank you. About the remote signing service, I'll just give you the control of the screen. You should be able to do that now. I also ask if you can try and keep it to 20 minutes, and then I'll give Olivier half an hour on his two subjects, if that's okay. Then we've got 15 minutes closing discussions. Over to you.
See my screen with the presentation?
Yes, I can.
Okay, perfect. Okay, so I will give an overview, or this presentation is to give an overview of the different standards for remote signing. So I will introduce, there are different documents, so I will go through the most important one in this area. So first of all, I will kind of explain what we mean by remote signing. And this picture, I think, gives a relatively nice overview on how the different documents feel, which role they play. So we have a signer on the left side who wants to sign a document. And then he sends this document to a trust service provider service component operating a remote qualified signature creation device or a signature creation device. So why do we talk about a TSP component and not a TSP service? Because from EIDAS, the managing of a key is not a service. It's not, at least not a qualified service. And the managing of the key could be part of different TSPs. It could be part by a CA, of a C8, or it can be part of other trust services. So what we do here is we define requirements for the component, which then can be implemented by different TSPs. So we have the protocol between the server, the application on this side of the signer and the trust service TSP service component. The protocol on this is the ETSI document TS119432. And then we have the ETSI document TS119431, which gives the requirement of the trust service component. So those are the two ETSI documents on this area. And then we have within the service component, we have different elements. We have the server signing application, which talks to temporary protected environment, where there's the crypto model really managing the key, and where there can be a signature activation module, which allows to access to the key or not. So we have the CEN document 419221 part 5. It's the protection profile for TSP cryptographic modules. So cryptographic models for trust services. We won't talk about this one. It's kind of the only one we kind of take aside, which is in this picture. I will talk about the other documents there. So the EN, the CEN document EN 419241 part 1 talks about the combination of the server signer application and the key in the temporary protected environment. And then we have the EN 419241 part 2, which is a protection profile on the how to manage the signature activation module. So some elements are outside of this service component. This is the issuance of the certificate, the revocation management. Those are part of the registration. Those are all part of a CA. And some parts that can be outside is when the authentication of the signer is delegated. So this can also be partly outside of of the area. So on the next slide, I now will talk about the CEN document EN 419241. It's on the trustworthy systems supporting server signing. There are two parts. So it's part one, the general system security requirements, and part two, which is the protection profile for QSCDs for server signing. So it's really, the idea was to have standards which can be then referenced in IDAS. It's not yet referenced, but it can be referenced for the usage for qualified signature creation device. And what is important, which kind of is reused again quite a lot, is they have two levels of sole control assurance. The sole control assurance levels, SCAL 1 and SCAL 2. And SCAL 1 means that the signing key are used with a low level of confidence under the sole control of the signer. And the authorized signer use its key for sign. The use of the key for signing is enforced by the server signing application, which authenticates the signer. So it's the server signing application which manage who has access to the key or not. And then we have SCAL 2, where the signing key are used with a high level of confidence under sole control of the signer. And here it becomes more complicated. We have the more different elements here. So the authorized signer's use of its key for signing is enforced by the signature activation module, the SAM, by means of the signature activation data, the SAT, provided by the signer. So the SAT is provided by the signer using the signature activation protocol in order to enable the use of the corresponding signing key. So I copied the definition here because it's difficult to get the formulation exactly right if you don't use the exact wording, but we have the signature activation module, which takes the signature activation data, and the signature activation data is created using the signature activation protocol. And all this is needed for SCAL 2 to allow the usage of the key. And this level aims at supporting qualified electronic signatures. That was kind of the main goal of it. Then here are two figures I also took directly from the CEN document, which explains a bit more how the different elements are. So we have the TSP, protected environment, where there's the server signing application. And the signer authenticates to the server signing application, and then the server signing application says to the SCD, allow the usage of the key. So this is the idea of SCAL 1. For SCAL 2, we have now all the elements that we've seen, I described before. So we have within the temporary protected environment, the signature activation module, which is before the signature creation device. And it's the signature activation module which will allow the usage of the key. And what's the big difference is, now it's not the server signing application which says, okay, sign the key, but the SAM directly communicates with the SIG, which is the signer interaction component. So there is a direct connection between the signer and the SAM. So nobody within the SSA could sign without the acceptance of this of the signer. That's the main idea of SCAL 2. And yeah, that's. And what is also important is that the SAT, the signature activation data, should have a link to the data to be signed representation. So the document we want to sign, who wants to sign, so the authenticated signer, and the key to be used. So all those elements need to be connected. The SAT and should not be, it shall not be able to kind of use the SAT for signing it with a different key, with a different signer, or with a different document. So this was on the CEN documents. Now, what are the ETSI documents in this domain? So we have the ETSI TS 119431 Part 1, which is policy and security requirements for a trust service provider implementing a service component operating a remote signature creation device. So we have a lot of acronym in this presentation, so I do my best not to get you lost completely. So we have the server signing application service component, meaning we have a service component that does the work of the server signing application. So kind of gets the hash to be signed, and then talks to the temporary resistant environment and to start the process of signing. And depending on the level, it can directly authenticate, say, okay, do the signing, or it's done via the set. So we have the requirements, and this document heavily uses the requirement in the CEN EN 419241. It also is based on general requirements for TSPs, so it kind of gets those tools input and get the best practice for remote signing. It defines 3 SSA-SC policies. The first one is a lightweight policy, which is less demanding than the NSCP, which we'll see later on, and it's linked to SCAL1. We have the NSCP, which is a normalized SSA-SC policy, which is the general recognized best practice and linked to SCAL2 in the CEN document. And then we have a last profile, which is defined in an annex with the EU SCP, which is a policy specific to European Union, to EIDAS, and links the EIDAS regulation with specific requirements on the QSCD management, but it heavily is linked to the requirements of the NSCP. And as in many other ETSI documents, the main document is kind of EU independent, and the annex is specific to the EU. And this service component, the server signing application service component, handles cryptographic signatures, meaning we just do the signature of the hash. We don't care about signing attributes, signature form, or something like that. For this, we have part 2. So part 2 provides policy and security requirements for trust service providers, implementing a service component supporting others' digital signature creation. So a new acronym. We have the signature creation application service component. And the idea here is we have the signer, which gives the document to be signed and maybe some parameters to the signature creation application service component. This one will talk to, for example, the CA to get the certificate. So we want to use in the signature, to include in the signature. And it will talk to an SCD for the cryptographic signature. This SCD can be managed by the signer or by an, there's one S too much, SSA-SC, so that's independent. So here we only look on the part of how to create a service component that wants to create other signature, what they have to take into account. And for example, a remote signing application can implement both service components, the SSA-SC and the SSA-SC, or it can be done by different ones. What we wanted to do is be able to separate really those requirements. And then we have also, like usual, a protocol documents. So it's the 119432, and it's a protocol for remote signing. It covers both cases, the server signing application service component and the signature creation application service component. It allows the creation of cryptographic signatures, and it allows the creation of other signatures. It does not cover the creation of the set. Where here in this, so the let's say the value set as is used in the document, so it's an input. It's not defined how it's created in this document, and it's not. It's more used in the more general sense, in the meaning of a signature activation data, but not necessarily for SCAL2. So you could have a SCAL1 level and create a set which is provided to some activation data that is provided to via the protocol, but which is not necessarily talks to a signature activation module or created by a signature activation protocol. It defines the main functionality of the protocol. So it's also, you don't need to, there's some flexibility. For example, it's the possibility to have asynchronous or synchronous calls. Server that don't need to do everything. You just have to decide at the beginning which part of the protocol they want to support. And there are two different implementations of this protocol. A JSON one, which is based on the Cloud Signature Consortium specification, and an XML one based on OASIS TSP. So we wanted to allow both cases, and it's kind of there were different standards to go to for them. And what we tried to do is have the general functionalities, and then depending on which standard you want to use, to implementation of this protocol. And then at last, I want to talk just a few words on the Cloud Signature Consortium specification, because I'm also the chair of the technical working group there. So you can find more information under this link. So it's a specification which was first published, the 1.0 version in 2018. And there's work going on to get a 2.0 version, because there is the 1.0 version provides a protocol for remote signing based on JSON and REST API, but originally just for the signature of the hash. It's also for timestamp, but it's not. It does not yet allow the creation of the signing of a document. So 119431, allows the additional parts with signing of the document, and also the asynchronous calls, which is not implemented in the 1.0 version, but will be implemented in the 2.0 version. However, what is covered by the Cloud Signature Consortium specification and is not covered by the protocol document of ETSI is some mechanism to create the set, not SAM, the set, the signature activation data. And the principle is to have a very flexible protocol that allows the signing application to discover which specific functionality a server signing application supports. So more or less, the server signing application can decide what they want to do, and then the signing application should check what they have and then calls the corresponding function. And the 2.0 version will contain the features that are implemented in 119432, like the other signature and the asynchronous call, and also more possibilities for the credential authorization for the creation of the set. Okay, I think I was probably a bit faster than planned, but this probably helps to be in time for the rest of the document. So that was all from my side.
Thanks very much, Andrea. I noticed in the questions, but there's quite a lot of questions, so you may find yourself coming back on some of these issues. So perhaps whilst they're looking at Olivier's presenting, could you just have a look at the questions? There's a number of questions to look at, and we'll see how much time we've got at the end. Okay. Thanks very much, Andrea. Right, so I'd like to pass on to Olivier, who is going to give a closing session on trusted lists and mutual recognition. So over to you, Olivier. We can see your screen in editing mode at the moment. If you can try and keep it to half an hour, so we've got enough 15 minutes at the end. But over to you. You're muted at the moment.
Yes, indeed. You see my screen?
Yeah, we can see your screen, and we can see you as well.
Fine. So I will first talk about the trusted list, and basically what is the trusted list. It is actually the constitutive legal instrument that is used by EU member states to declare and confirm actually that who is a qualified trust service providers and who, for which type of qualified trust services. So a trust service provider may not enter the market in providing a qualified trust service if it has not been granted the qualified status, and that status be confirmed in the trusted list of the competent member state that is supervising the trust service provider or the qualified trust service provider. So it gives, as an instrument, a legal certainty on what is qualified and what is not qualified. It is mandatory for the EU member states to list the qualified trust service providers and the qualified trust services for which they have been granted a qualified status. On a voluntary basis, each member state may also list, based on the national approval scheme, non-qualified trust services and non-qualified trust service providers, but it is not a general practice. In terms of technical aspects, the trusted list is an XML file, which is formatted against not really directly a standard, but an implementing act. So a secondary legislation, which is linked to the ADAS regulation, but which is building on top of the ETSI TS 119612 version 211 for being precise. And it is actually profiling the hierarchical structure of the XML file with trusted list information, a list of trust service providers. For each trust service providers, we have every trust service that is listed, and for each trust service, the full history of the approval or qualified status of the trust services. So it's a signed XML file that can be processed in an automated way. In order to process these trusted lists, there is very recently published standard guidance for the interpretation of the European member state trusted list, as it is specified and defined in the TS 119615. So in terms of structure, you will find the XML being organized by providing first information about the trusted list, the scheme and its operator. So who is the entity which is operating the trusted list, name, postal and electronic address, information on the trusted list, the territory, on the supervision scheme, which is used by the supervisory body or the trusted list operator to approve a trust service providers, give them a qualified status or a nationally approval status. Information about the scheme, the legal context, the date of issuance, the date of expiry, and as much as information that is needed on how to use and interpret the trusted list. You may also find pointers to other trusted lists to interconnect different trusted lists between each other. It will be key, as we will see later on in the presentation, for implementing mutual recognition between different systems, different countries. But in the EU, you have to see it as a block. So all the EU member states are part of the same scheme with regard to the approval and qualification of the trust service and trust service providers. And we will see that there is a way to facilitate the discovery and the verification of the authentication of the member state trusted list with a tool which is a list of the list, which is a compiled list of pointers to the different member state trusted list, which is managed by the Commission and signed by the Commission as well. Within the trusted list, you have a list to a structured way, the list of each of the trust service providers which are supervised by the member state, whether it is qualified or not, specific information or contact information for the TSPs, enough information for relying parties to identify what are the practices, the policies, the general terms and conditions, whatever legal information is applicable to the different services. And per trust service provider, you have the list of all the qualified or non-qualified trust services identified by a public key, which serves as a trust anchor. So the public key is the digital identity of the trust service entry. It is conveyed by at least one certificate, but if there are more than one certificate, they must relate to the same exact public key and also subject name. So you can find and extract from this information what you need as a trust anchor information. You will find for each service the service type. So whether it is for the issuance of qualified certificates, for electronic signatures, for qualified timestamp, for national archiving services, if it is not a qualified one. And also you will find the current status. So at the time of the current time, you will find the exact status of the qualified or the approval status of the service. But also you will find the full history for the grant or the withdrawal of this qualified status or approval. So if you use the different types of tools that can be used to browse as provided by the Commission, or for the TL Manager application, you can see the structured information where you can, per type of trusted list, find information about the qualified trust service providers and about the historical information and current information about the trust service. When using trusted list in the context of what we have seen earlier today with regard to the validation in particular of the signatures, so assume that somebody in the EU has created a claimed qualified electronic signature on a document. When validating the signature on this document based against the trusted list to verify the qualified status of the signature, then you will actually apply one specific standard that deals with these specific technical applicability rules that you have to process when checking the qualified status of a signature against the trusted list, which is 119172 part 4, that will leverage on the usual validation process for the signatures, which is the EN 319102 part 1. And building on the result, you will apply 119615 to verify the qualified status of the signature. Basically, in this case, of the qualified status of the certificate, whether it has been issued by a qualified TSP, qualified for the issue of qualified certificates for electronic signatures, and whether the private key resides in a qualified signature creation device. So that you can verify from the trusted list using all these combination of standards. The standard 119612, which specifies defines the specification for the trusted list, also allows for grouping the different countries' trusted list. In the case of EU, or the 27 plus 3 EEA countries that participate to the schemes, in a list of the list by means of pointers. So it facilitates the discovery, but also the authentication, because the Commission is actually publishing this compiled list of pointers to the national member state trusted list with all the different certificates that can be used in a secure way to authenticate the member states' signatures on the trusted list. And the location and the certificates that can be used to validate the list of the list signed by the Commission are published in an official journal, and there is a very specific concept of pivot list of the list that provides also a way to automate the discovery of new certificates and the new renewal of the certificates and even the location of this. So these standards are very powerful in order for any country in Europe, but also in non-EU countries in the world to set up trust representation of approval status that has been given by a regulatory framework or a contractual framework to a specific type of trust services. So indeed, 119612 can be used by non-EU countries. So if you read these standards, there is a very specific set of specification for EU countries, but also what you need to do if you are from a non-EU country, so an international organization, in order to implement a trust representation of which type of service was or was operating in compliance with specific requirements that are defined on national level or regional level. You can also mimic the list of the list concept by grouping different countries that adopt the same or similar regulation with regard to trust services. A few tips and requirements that we will see a little bit also more afterwards when talking about the facilities that the Commission has provided for on a technical purpose to facilitate the preparation to a mutual recognition with the EU. Do not make use of EU specifications if you are a non-EU country. So define your own service type identifiers, service statuses, or qualification or approval extension that are applicable to your regional, national legal framework, and define also benchmark for the content of certificates or content of specific token that would declare compliance with your national or regional requirements. Also the 319412 series and in particular part 5 allows for non-EU countries to adopt the same concept but with very specific national statements. With regard to the trusted list are what we call an instrument to demonstrate or to declare the representation of the trust that is given to some trust services and trust service providers within a very specific context. So when we deal with not only on a national context or a close membership, but we want to extend the recognition to behind the boundaries of the national, then we talk about the mutual recognition of electronic signatures, and it can apply to a bench and various types of trust services, not only those which are defined in the EIDAS regulation, but also extending to archiving, which is currently not a qualified, not even a trust service in the EIDAS. It might change in the context of the revision. But these are key building blocks for which you may search for an harmonization with regard to the law that are regulating these, the way they are supervised and audited, as Arno mentioned, and also which kind of technical practices are used so that you can facilitate the recognition and the equivalence assessment of the equivalence of the trust services so that you can rely on each other's. In order to facilitate this mutual recognition, or at least the assessment of whether different types of similar purpose trust services can achieve the same goals, the same equivalence in trust and be used in cross borders, there is a 4-pillar methodology which has been identified or defined in the ETSI technical report 1036A4 with a view to use it as a benchmark for establishing a methodology to assess the equivalence of the legal context which is driving the implementation of trust services, or they are supervised and audited. What are the best practices or the technical specifications that are used, whether they are interoperable, whether they are equivalent or not, and how to discover and to represent the trust in a common way. So if you back to the pyramid of trust, which is actually, if you look at the European one based on IDAS, which is leveraging on the best practices and standards, but which is driven by the ADAS regulation in terms of legal provision, building upon a supervision that has been already addressed by Arno with regard to a 2-yearly process for demonstrating that you comply with the requirements based on an audit and regular audit every 2 years, with the possibility to have ad hoc audits and even a termination process to make sure that the service are left in the correct state in order to maintain the trustworthiness and the legal certainty of the provision of the qualified trust services, and everything is presented and represented in entrusted lists. So these trust representations, supervision, auditing, and legal context and best practices pillars can be used by different regions, different countries in the world in order to assess whether they have equivalent frameworks for the implementation of trust services. I will go briefly in the legal context. So what needs to be assessed is, of course, whether it is driven by law or by contracts. What are the general principles in the context of trust services in the ADAS, and also in the context of the benchmark that is currently under finalization at United Nations for the Working Group for Electronic Commerce, that is aimed to finalize a model law for 2021. You have usually general principles like non-discrimination on, again, the use of electronic means, technologically neutrality, which does not mean that you cannot, in second legislation, point and prescribe or mandate even specific standards or way of doing it, provided that you are open to innovation and to add additional standards or additional technical specifications for new technologies, functional equivalence. You can define what type of trust services you want or you seek equivalence for. The level of reliability, whether it is called qualified or non-qualified, licensed or registered. You have to assess the different types of obligation of the TSPs, of the users, or they are recognized by by public services or private platforms, and what are the basis for the international recognition aspects, whether it is unilateral, that you say on your own national basis, okay, I accept these and these and these based because they are meeting my requirements, or you, as in the context of the ADAS regulation, you are seeking for a reciprocity, so you impose that the foreign TSPs and trust services are meeting the requirements of the regulation in this case, but you also require the reciprocity. So this is not really technical, but it is a huge aspect of the mutual recognition. And the second one is not less important, which is the once you have granted an approval or status or a qualified status to a specific type of trust service provider and the trust services provides, or you are supervising and auditing the fact that it meets the requirements and it still continue to meet the requirements until and even after the termination, then you have to define a set of requirements for the authorities that are approving the conformity assessment bodies or the auditing bodies. What schemes are used by these bodies to audit and conduct the audits? What are the requirements? What are against what and which type of criteria they will assess the conformity of the TSP, whether it is against a law directly or legal provisions or a technical standard or a mix of both, because you have secondary or third legislation that points to different standards for either on a voluntary basis, on a mandatory basis. What are the requirements on the assessment reports, or you take decision based on the reports, and or you represent this in the trust representation, whether it is trusted list or another mean. In the context of ADAS and in the ETSI standards, as it has been identified by Arno earlier today, the model is based on the IF MLA with regard to the certification of products, services, and processes. So the ISO 17011 for the national accreditation bodies to accredit conformity assessment bodies based on certification. So we are talking about certification bodies for product and services and processes. But ISO 17065 is for whatever type of, all kinds of products, services, and processes. So the level 4 in the context of the accreditation of the conformity assessment bodies and of the audit is the standard 319403 that has been mentioned by Arno, part 1 today, which is fine-tuning and supplementing ISO 17065 for the very specific type of trust service and trust service providers being assessed by the conformity assessment bodies. And then you have to define against what list and specific list of criteria they have to be conform, or the conformity is to be assessed, whether it is in the context of the eIDAS, the legislation, the regulation itself. So they are not assessed against standard in the context of eIDAS, but against the regulation. Of course, they can build upon best practices and the standards defined by ETSI and CEN. But the conformity assessment report needs to confirm that they are meeting the requirements of the regulation, not of they are meeting specific standards. Then either in the context of the equivalence of different frameworks between EU and non-EU, for example, or from different regions of the world, you have to either define the same technical basis and technical requirements or technical standards, or you have to assess an equivalence of the legal provisions and the technical criteria. So there is at least a strong recommendation or encouragement for promoting at the level of the different regions of the world, and certainly starting from your national accreditation body, to promote the 17065 certification process, supplemented by the 319403 for the assessment of trust service providers and trust service that you are supervising and seeking equivalence. And then either the normative documents are exactly the same, or they are also assessed as being equivalent. In the context of the eIDAS regulation, one of the requirements is that the TSP, the foreign TSP that are seeking equivalence with the EU qualified trust service providers and the qualified trust service they provide, they must meet the requirements of the eIDAS. So there is immediately available a set of about 30 accredited CAPs in eIDAS, and benefiting from the IAF multilateral agreement, certified ones recognized everywhere. You can also rely on this basis of conformity assessment bodies to speed up whatever type of mutual recognition you would like to seek with the EU. In terms of best practices and standards, well, you have received today a lot of descriptions and insights, information about the different standards that can be used to support the provision and the implementation of different types of trust services. The more the more common the basis of the technical specification is used for the implementation or the prescription of the implementation of the trust services, the better, of course, because then there are less divergence, there are less deviation. Even if you are using the same standard, sometimes the interpretation can be different. But you see that outside there are also plenty of different types of standards, for which the challenge may also be the real interoperability between the different implementations. But usually we say that technically everything is possible, and they might be the legal and the supervision pillars that are the more difficult one. In terms of trust representations, there are also different models that can be used to represent the trust. The trusted list that I've presented a bit before, but you may also have simpler ways of implementing trust representation, like trust or certificate stores, or you can also implement bridging and cross-certification. You may also combine all these type of things, and there may be also technical ways to map between the different representation and convert the information coming from one to another one. But if you are seeking a recognition or a mutual recognition with the EU, then I'm afraid that the trusted list will be a key instrument and a prerequisite. But to this extent, I will continue saying a few words on the tools that are provided by the European Commission with regard to the facilitation of, or the starting point of initiating and assessing whether there is a readiness for the mutual recognition with the EU qualified trust service providers in the context of EIDAS. So the European Commission has provided a bunch of information with regard to the technical aspects of facilitating a pilot or a technical pilot for assessing the international compatibility of the trust services, and in particular with the European qualified trust service providers and qualified trust services. So it's a generic model and bunch of documentation that can be used by any third country. It is, and you will see that it's reusing and leveraging on different standards from ETSI. So it builds the methodology of assessment on top of the ETSI tier 103684 4-pillar methodology. So the European Commission provides a cookbook with requirement for third countries to facilitate the alignment with the trusted list, but also a checklist that present a structured approach for the 4-pillar. So based on a self-assessment, a third country can perform a maturity check with regard to the readiness of the equivalence in the legal context, in the supervision and auditing, technical specification, and the trust representation. And would it be ready for implementing a mutual recognition agreement? Then the way to express and execute this mutual recognition agreement will be a pointer to the national trusted list, or the third country trusted list, a bilateral pointer. So in the list of the list, there would be an additional pointer to the country that is recognized equivalent for certain types of qualified trust service providers and trust services. And this pointer would express the mapping between, let's say, this type of trust service, qualified trust service providers. So let's say that qualified timestamping in the EU is equivalent to qualified time information, or and this type of service information, and also provide all the mapping is done with regard to the qualified, the approval status or the qualified status. And it will also give an historical information about the recognition agreement and even providing some hints and guidance on how to validate signatures between the different frameworks that have been recognized equivalent. So building on top of 119615, that is the procedures to consume the European trusted list, there is an addition specification which is provided by the Commission to consume the pointer, the mutual recognition equivalence pointer with the third country. It even provides toolbox for technical pilots, so different elements that can be used to test the implementation of the trusted list. And it is seen as a starting point for a complete mutual recognition agreement process, which can be a long journey. But this pilot is focusing on the preparatory phase for these aspects. So it's purely on technical part. There are, I will not go into details, but with regard to the benchmark that are used today by the European member states trusted list with regard to the ETSI standards in terms of how to indicate the declaration of being qualified when you are issuing a qualified certificate, whether it is supported by qualified signature creation devices, what are the specific values that you should use in a national trusted list to facilitate the recognition and the equivalence of the mapping between the different trusted lists, the EU one and the non-EU. All these types of requirements are described in the CEF pilot documentation, and there is a set of requirements, technical assumptions, and recommendations, mostly building on the implementation and profiling on the ETSI standards, achieve in the most easy way and facilitated way a technical, at least, consumption of the validation of or the implementation and the recognition of the equivalence of the trust services. And so the pilot is really aimed to make sure that whether you are signing or verifying an electronic signature, in this case, or seal or timestamp, that is qualified from the EU side, and whether you want to verify that it is equivalent to the recognized level in the third country, and vice versa, if from a third country you are creating an electronic signature and you want to verify that it is equivalent to a qualified electronic signature in the EU, that you can, exactly as I presented before, when consuming the trusted list, you can use validation services and procedures which are standardized in order to consume either the national trusted list of the third country, and using the pointer go back to the list of the list to the national list of the EU member state, from which the counterpart qualified trust service provider is supporting the electronic signature that you have received, and vice versa. You can use the national trusted list or the list of the list to verify and to point to the third country recognized equivalent framework for verifying the equivalence of the qualified status. So these technical aspects are pretty much defined and specified thanks to standards built on the ETSI standards and CEN standards. And it can pretty much facilitate the technical consumption and the technical implementation of the mutual recognized consumption and use of, without borders, of the trust services. Of course, this is not the sole pillar for which you have to seek equivalence. You have to deal with the legal and regulatory, with supervision and auditing, and indeed the devil is in the details in the implementation of the technical standards. But at least there is, I think you have been presented today with a complete and comprehensive framework for the technical specifications that fits directly in the context of a more broader and pragmatic way of approaching the recognition at a legal level, or at the supervision level, or even at contractual level. So thank you for listening to me. I'm a bit over 30 minutes.
It's very good. Yeah, thank you very much for keeping within time. I'll just say a few closing words, then we're going to run a bit over time if people want to carry on for another quarter of an hour. So we're running a bit late, but I think it's useful to answer some of the questions. I've tried to record some of the points. I'll first of all just take the screen and show my closing remarks, mainly just so that you know where to get further information. So I believe I'm sharing my screen. Yes, so you can see my screen. So just a few closing remarks. Then I'll ask my colleagues to also come in, and we'll answer try and answer some of the questions. So as mentioned in some of the sessions, we're working on updates and we're continuously working on new aspects. I won't go through all the details, but in this slide, we just show some of the areas where we've got updates. So we've got updates on CADES and ZADES just coming out. We've worked on updates to the 411 related standards, which are about to come out, and we're almost immediately starting on further updates. So the basic point is watch this space. There's more work carrying on. For further information, there's an activities page which shows all the current activities, and you can download the page, the documents from the standards page or on ETSI, or there's a CEN standards download page. There's an email address, and also if you want to get the slides and recording of this session, then this will be made available on the same website as we use to announce and register you on this website. We're imminently due to get some updates for EIDAS, which we'll have to take into account. It's likely to include work on EID, which currently has been not addressed by ETSI standards, but it's possible to work on pan-European electronic identities. And like everyone else, blockchain technology and DLT is affecting our work, and just keep an eye on this space. So just can I ask everyone else in the other presenters to just join, show their screen and join the presentation. So I've got Andrea and others, if you can come join us. Thank you everyone who presented. He did a fantastic job. I'm just showing a few of the points I identified. I'm not sure how much we're going to cover. I want to bring it to a close, at least in half an hour. But I've got a list of issues which I recorded. Depending on time, we'll have to answer offline. But can you, Andrea, I think you put your hand up on pseudonyms, which I've had several questions on pseudonyms and GDPR, and can you answer the question if you can?
I'm not sure if I can answer it in completely, but I will try to give a first or interpretation how this is handled in the different standards. The thing is, within the EIDAS, we are it's stated that advanced electronic signature must be uniquely linked to the signatory and capable of identifying the signatory. Does not mean that you have to put your name in there, but it must be possible from the signature to identify who signed the document. And how is this now supported if you don't want to give your name in the different standards? First of all, in the certificate protocol, it's possible. It states that it's possible that within the certificate, you don't put the name of a natural person. You can give a pseudonym. So that is possible in the certificate itself to put a pseudonym. What it's also in the validation report, for example, if you have to give the identity of the signer, and if the identity, if in the certificate it's the name, you will provide the name. If in the certificate it's the pseudonym, you will just put the pseudonym of the signer. And what it's also for, why it's important to have at least one entity at some point kind of identifying somebody, it's to be able to have this, that can guarantee that the signature kind of can be linked back to the signer. And also for the remote signing, for example, it's very, very important that we guarantee that the access to the key is done by the same person who is identified with a pseudonym or no name in the certificate. So there needs to be at least some links, but it's not necessary to have the name of the signer directly in there. I hope this answers shortly the question on that.
Yep, thank you. Is there any other comments on that? I just want to mention we don't standardize a format of pseudonyms, but we support the ability to carry pseudonyms within the protocol. And they're always linked to the same key, so it's traceable at least to the key. Any further points? Okay. Anna, did you want to add anything or?
Not on pseudonyms, just about question number 4.
Okay, we'll come if we deal with them in order. So human readable policies, again, Andrew, you put your name down first, but I think if anyone else wants to come in on that.
I give my
Yeah,
I get something, I let Juan Carlos.
Yeah, well, my memory is not as good as yours. I've got a vaguely remember. I mean, I make a vague reminder of why we made that decision. Okay, but you start first because your memory is better than mine.
So yes, it's true. In the human readable version, it's possible to reference different signature policies, which allows you to have a hierarchy in the whole structure. It was we decided we thought about doing the same thing in the machine readable policy, but the problem was then for each requirement you have to say, okay, which is the one that taking into account, which is overrides the others, and that just made the structure so much more complicated. So we've decided, keep it simple. These policies are there to give specific rules that you implement directly to create or validate a signature, and it's so much easier to just have one level in there and don't do the same possibility which is in the human readable, but just to avoid that the structure becomes too complex.
Okay, well, I noticed that that I was right. My memory did not fail me this time. I just wanted to add one other reason why we decided not to include that. And it's that the reference XML policies could have, to some extent, certain contradictory requirements, and then this would imply these precedence issues as appointed by Andrea. The only thing that I wanted to mention is that although it is true that you cannot include this structure, nothing prevents for let us say the designer of the signature policy, the one that produces the readable signature policy built on other bricks, other signature policies, to make the exercise of putting together all the requirements in the order and the precedence that they want in one single XML document. There is nothing prevents that. It's a tedious probably exercise. It must be performed with a lot of care, but well, nothing prevents to get a unique XML or ASM1 structure with all these precedence rules that Andrea has mentioned before implemented there. I mean, nothing prevents that. And then the rules, the XML requirements, in the end, the XML signature policy and the ASM1 signature policy are defined for facilitating the automatic processing of certain rules. That's the whole story about this XML and the ASM1. So if you build, if you are able to take the written statements of all the bricks and encode them in one unique XML or one unique ASM1, then you will facilitate the applications to apply the requirements during the validation of your signature.
Okay, thanks very much. Another one for you, I think, Juan Carlos. Perhaps you can give us a few examples of signed attributes. And there was a question whether you saw the question about commitment type and GDPR,
yes.
which I...
Yes, we've got this commitment type, for instance, saying, okay, we've got a number up to 6 or 7 different standardized commitments. I mean, we have identified up to 6 or 7, I do not remember very well the number of commitments, like, okay, I have witnessed this document and I sign this document as a witness or as a generator of the document and this kind of things. Other signed attributes, as I said, are attributes owned by the signer, meaning, for instance, an attribute certificate. It's an example of attribute, of signer attribute. But also it could be a signed assertion got from some entity which has the attributions for generating such assertions. And finally, also there are another signed attributes, like, for instance, the format and the type of the document that has been signed, and this can be used by the relying application for instance, showing the document in a certain way or the other to the relying party. And finally, the timestamps on the data objects of the documents that are signed that prove that those documents existed before the instant enclosed within the timestamp token. These are the and also the claimed signing time. I mean, it's the time that the signer claims to have performed the signing act. It's a claim because it's not, well, the relying party does not have necessarily to believe the signer. And if the relying party needs more trust, probably the relying party will request a signature timestamp. Okay, these are some of the examples of signed attributes.
Thanks very much, Juan Carlos. Can I pass on to you now, Arnaud, on this question of just clarifying who sends the audit report? Because I know legally it's the TSP, but the auditor has a key role in working in this process. So you can say, do you want to say something on that?
Just, I think it's handled differently in different countries, but reading IDAS Article 21, it's quite clear. The TSP should send it to the SP, supervisory body. So that's quite clear stated within IDAS. So it has to be done by the TSP to the SP.
Yeah, but still, presumably the supervisory body still needs to check that the audit report comes from the auditor, and there's quite a lot of dialogue between the auditor and the supervisory body.
Or maybe a trialogue, yeah.
Trialogue, yes.
But formally, it's
formally, yeah. Okay, but there was some questions, Sylvie, I got on remote identification, talking about documents versus biometrics. I believe you take account to both approaches in the
Yes, however, I could not find the question exactly. So if you have it in front of you, you can read it to me. And in the meantime, I can say that yes, there are requirements for extracting the biometric information from a digital document, here, ID card, for example, or passport, and then perform the check between this information which is extracted and the person which is beside the document, and automatically check that it is indeed the same person. And depending on the fact that there is a human registration officer at the other side of the channel, or that it's artificial intelligence, then you have maybe additional check in the second case. I don't know if it was the question.
Yeah, no, I can't find it myself now. If someone want to say about, on behalf of Adobe, their support on trusted lists, because I know they put a lot of effort into trusted lists. Or shall
I can say something if you want, or somebody else.
Yeah, yeah, if you say something.
So they, in the Adobe Reader, they have two sources of trust. The one is their program, the ATL program, and the other one is the trusted list. So they extract the certificates which are on the trusted list, the current trusted list, to see if a certificate is can be trusted, comes from trusted CA or not. So yes, there is some support for that.
Yeah. And I think we've worked closely with Adobe since going back 20 years almost, but yeah, so Adobe have been very active and supportive of our work, and that they have integrated with PDF all the work we've done on the PADES as a PDF. Exactly. Is fully supported by.
Yeah, in fact, they were in the team that standardized that made the initial standard on PADES.
Yeah. Okay. I don't know whether, Andrea, I was flooded by further questions on remote signing. Anything that you would particularly want to say, or should we just?
I answered most of them in the chat. So there was maybe one question. It's, will the document be referenced at some time? Hopefully yes, but it's not in our hands. So there's the group of experts of the European Commission that decide what to put in the implementation acts. I know there's a plan to do that, but it's not clear until when and under which condition this will exactly be done. So.
Okay. I don't know, Olivier, are you online? Or
yes, indeed.
Okay. Can you, if you want to show your face, please turn on your screen. Otherwise, just answer the last question I've got, which is, we've got article, is it 14, that talks about cross recognition, but can you say something about linking that to trusted lists and what?
So actually, so indeed, the legal basis for the mutual recognition is Article 14. So the formal procedure is related to the execution of an international trade agreement, and within this context, you can have an assessment of the equivalence. So the third country TSPs and TS must meet the requirements of qualified trust service providers and qualified trust services. And actually, it is the specification, so the way the member state trusted lists are formatted, specified, and implemented is driven by an implementing act. The list, which is compiling all the list, the pointers to the European member state trusted list, and the way it is done to authenticate, to facilitate the authentication of the European member state trusted list, has been left to the Commission, even in the regulation. And so it is by publishing specification and documents in the official journal that you can derive the conditions to validate and authenticate the European Commission list of the list. In this context, when there has been a lot of third countries and knocking at the door of the European Commission for seeking, or it would be in practice possible to implement such a mutual recognition agreement under Article 14. Then the Commission prepared some guidance and technical facilitation pilots and information with regard to how it could be executed. And it was presumed that the list of the list could be a technical mean to represent the execution of the mutual recognition agreement. And that is what is described in the CEF pilot for international recognition with that country. So the documentation that I've provided the link in the answer to the question and also in the slides. And you will see that so far there is no mutual recognition agreement that has ever been completed today, but as a day of today, it is expected to be the technical mean for expressing and executing a machine processable recognition of or the expression of the such an agreement. It may change in the context of the revised version of the regulation, but so far it is the way it is, at least published by the Commission.
Okay, I've just found that there's a question about creating subkeys under a member of a trusted list. I think this actually, you've answered asking for more answers, and this comes back to kind of operations such as remote signing. So when you've got a sub-component that's operating remote signing, I presume that's whether you or Andrea, whether this relates to how do you authenticate or assure a sub-component such as a remote signing component and a TSP operating remote signing. How does that work? Whether you want to, or Andrea, answer that, or shall I have a go?
Yeah, I'm not sure I've understood the question or the original question. So whether it was related to remote signing or not, I don't know.
Yeah, so well, there's a follow-up answer relating to remote signing, which to me relates to subcomponents. So the way it works at the moment, any remote signing component has to be part of a TSP. So it is identified in the trusted list by not a subkey, but by the key in the trusted list. Is that?
Yeah, you have to distinguish between the keys from the users and the keys from the trust service providers. So
it's a key of the trust service provider, I assume it's talking about.
So either it is linked to the question whether the service digital identifier, so the public key which identifies a trust service in a trusted list, can either be a CA keys under which there can be different sub CA keys, for example. That is possible. So you can list a trust anchor or upper CA under which there are different types of issuing CA, but then the whole set is considered as being granted the qualified status. And if there is an issue, the whole set is being considered as withdrawn a qualified status. So that's the way you have to interpret the trusted list. Now, if the question is also related to the how it is audited that these keys are correctly managed by the trust service providers in accordance to the requirements, as a set of trust service and sub-trust services that are being granted the qualified status. This is the responsibility for the conformity assessment body to confirm the conformity with the requirements, and finally to the supervisory body to verify that this implementation and assessed implementation is meeting the requirements. So now if you are dealing with or talking about keys which are managed on behalf of the signatories by a QTSP in the context of the qualified signature creation device, it is completely different, because this has not been considered as at least a qualified trust service, so it is not listed. So the fact that you are acting as a QTSP, managing on behalf of the signatory the creation in the management of the signature creation data, this is not a qualified trust service, so it is not part of the trusted list.
I mean, there are some, you can, within a CA, add the extension managed on behalf of for a specific certificate. But the problem is the management is not a trust service itself.
Yeah.
But if it's the CA manage the key, then this information can be added. But yeah, there's some.
Yeah, there is a way to define this, but
yeah, it's not completely clear where to start with the trust service and where stops the device for the QTSP.
What is definitely clear is that this service is not a remote signing service.
Yes.
It is the management of the generation or the management of the keys. That's it, on behalf of the signatory. So it's like you have a butler for managing your smart card. You have a personal assistant to manage your smart card, but who is signing is still you, but the butler is not providing a qualified trust service. It needs to be a QTSP, but it's not providing a qualified trust service. It's not even providing remote signing services. It's just your personal holder and manager of your private keys. You have to see it like this, and it is within the boundaries of a qualified signature creation device.
Because we have a similar question: who checks for QTSP operates certain devices supported by a certain manufacturer? And I think it's up to the QTSP to, if it claims in the certificate, or is it's using a qualified signature creation device, then it's the responsibility of the QTSP. Is that correct, Sylvie?
Yeah, it really depends on whether it is a QTSP that operates HSM for its own purpose, so for signing certificates or for signing timestamps, and that he really respects the provisions or the requirements from the manufacturer when implementing it, and it is, for example, it is certified FIPS level 3, or it is certified even as a QSCD, but who verifies that the conditions that are prerequisite for this certification being valid are correctly implemented by the QTSP, then it is first the responsibility of the QTSP, of course, but then of the conformity assessment body that has to confirm that everything is put in place according to the declaration of practices and according to the requirements against which the conformity is conducted. And then if it is linked to a qualified status, it is a supervisory body that has to finally verify that everything is under control and according to the requirements.
Okay, thank you. I think we've got another one in the same area, but I think we'll have to answer that offline. I think there's a last question, and then we'll I think we'll break unless there's any other points that people want to bring up. Can a CA certificate published in the trusted list emit both the CRL distribution point and the authority information access? And I think this is a question of, can you be in the these trusted lists if you don't follow ETSI standard, because the ETSI standards require the CRL distribution point and authority and information access as relevant, but it's not required for being in the trusted lists. Is that correct? Sylvie, perhaps you're shaking your head on that.
Probably Olivier would like to answer, but we need to distinguish between the requirements on the end user certificate to have the CDP or AIA, and in the certification authority, it's not the same. But for what regards the certification authority certificate and the fields that are required in such certificate to be included in a trust list, Olivier, you can answer, but
yeah, you have to make the distinction because for the purpose of the trusted list and for the purpose of the confirmation of the qualified status, the public keys which are listed in the trusted list, they have to be considered as trust anchors. So there is nothing above that you have to verify. Indeed, for the end entities qualified certificates, but it applies as well to the CA if the CA claims that its own certificate is a qualified one. So it sometimes in the member states it is a case. So in this case, they have to include information with regard to the certificate validity status services. So there must be something. So it really depends, and you have to clearly identify what type of certificate you are talking about. And there is also a last question on qualified smart cards need to be on the trusted list, but remote qualified signature creation device not, as far as I know. Well, actually, there is no trusted list for qualified signature creation devices. There is a list which is compiled by the member state as an informative list for listing the devices that has been notified to the Commission as being certified as qualified signature creation devices. And both types of type 1 QSCDs, so the QSCDs where the private keys is held in the premises of by the user, and type 2 that are the remote QSCDs, so the QSCDs for which there is a QTSP that manages the private key. Both types are listed in this compiled list. So if you go to the trust services, the new trust services dashboard from the Commission, you will find a list of notified SSCDs for the old ones and QSCDs, and you can find both types of QSCDs, smart card-like and remote ones.
Okay, thanks on that. Is there any closing point on the questions that people want to make? Any of those? Okay, well, I'd like to thank all those who contributed to this presentation. I think we covered an awful lot, and I also like to thank the perseverance of those who stayed on to the end discussion. I noticed towards the end was falling off, but I think during all the presentations, we only lost 10% or something of the registered audience. So I do thank everyone for participating with questions and listening in. As I say, the slides will be available on the website for this event, and also we hope to have recordings made available if our recording system worked. And if with many major points we missed from the questions, we'll respond. I think we've covered most of the main points, but we'll have a review of all the questions and check that if there's any points we've missed. Okay, well, thank you for everyone, and I wish you a good day.
Bye-bye.
Bye-bye.
Bye.